Hi Anne, hi Mina. Bonjour Asna.
Bonjour, vous m'entendez bien?
Moi je t'entends.
Morning.
Salut, là c'est bon?
Yes, yes. Good morning.
How are you guys?
Fine. Thanks, and you?
Not bad. So little sleep. That's it.
Okay.
Yeah. So maybe you guys can already start to scanning the QR code on the and there and just fill in some forms. First of all is the attendance list. The other will be more about the data of your.
Hi, good morning.
Hello, morning. The other will be more about the data of yours.
Okay.
Hello.
Hey Ian.
How are you?
Yeah, fine. You
Yeah,
haven't
hi.
talked in a while, eh?
Sorry?
You haven't talked in a while.
Yeah, that's true. After the last WUS interview, I guess.
Yeah.
Um, yeah, I haven't managed to make all the plots yet, but I think we should have enough to discuss.
Okay.
We'll see. Maybe we can finish earlier today. So Stefan cannot give maybe he will only give like 5 minutes talk, but will be more update about his data set.
Hey, good morning.
Hello, morning. Morning.
Morning.
Good morning, everybody.
Morning.
Good morning.
Morning. So can all the speaker just confirm with me all the time slots are okay? Or does anyone want to present? We can also move a bit. I can give you some of my time if you want. Yeah, I'm not sure if
Seems like you have a lot of time there. Do you really need all this time?
I don't know. Let's see. Yeah, previously we had another, Lila, but I think we found out something wrong, then she needs to run the rolling again, so maybe it doesn't make sense to show it. So that's why we We don't have many speakers today. Yeah, but I think today's so far we only have 3 data sets left.
Is it correct that Stephen has only 5 minutes?
Yes,
Okay,
that's
okay.
he cannot get the results by today, so that's why he can only.
I know you're super organized, Ian, but I just noticed now. So
Yeah. Yeah. So, but Marta, I will give you more time about this seasonal versus rolling. I guess you will have quite a bit to show, and I suppose everyone will have quite a bit questions as well.
Okay, it's fine.
Sounds good.
And Ian, did you get a lot of feedback on this new 44, 43 plots and issues and stuff? Or
I think this issue, I asked most of people to redo it, and so far it looks good.
okay,
I mean, it will be different, but for Jenny's case, it basically solved it. But for others, I don't know yet.
yeah. Well, it's anyway more correct.
Morning, everyone.
Morning.
Hey there.
good morning.
Morning.
Yeah, maybe we wait maybe 3 minutes or so. Like, let's start at 9:35. So now if you have time, you can scan the QR code on the share screen to check in like the attendance list, as well as most importantly, you should enter the information in the station classification, the bottom left QR code. Each group has to submit one form at least. So I think I have looked into the actress website or something. I have seen quite a bit description of the your station, but it looks like it never classify whatever your station is. So that's why I ask you again in this form, so you can report consistently. So I only give you 4 options: urban background, remote, and rural. I think that should be sufficient. Rural background, I don't know if it's necessary, or mountain, Arctic, those maybe not necessary, in my opinion. But of course, you guys can change my mind. Just let me know. Send me an email. So if you don't agree with that. Yes.
Well, if you want to have it done by everyone, probably you need to send it by mail also, because a lot of people are not here, I guess.
I will do so, but maybe but I think now we can get more people to sign up for faster, at least.
Okay.
And Ian, if we have extra time, then you show us how to do these QR codes and in such a fancy way.
Sure. This is easy.
Clever.
We keep sending, boring links, usual links for Google Forms.
Yeah, so those 3 QR codes are all for Google, actually. YouTube to Google Forms. everything. Okay, so maybe we can start. I think we have 23 people already. Maybe, so let me just quickly ask, so Anna, may I ask you, is this time slot okay for you? Like, I know you you need to a lot of time to run the rolling PMF like since last week. So
Yeah,
have
and
you-
it's still running, so I'm just going to present the quick runs. So
Okay.
yeah, we've calculated, and I think that it's going to take like a proper 14 days. Yeah.
Oh, yeah.
Yeah. I don't know. Yeah, so it's still running on our server. Yeah.
Okay, so
Is that normal that it takes, is it taking much more than others, or why?
I don't know. I checked with our IT, and they say that yeah, I mean nothing is bad with that server. So, but maybe we need to investigate further. I don't know why.
What is the time resolution and
It's the usual time resolution. It's a very well, it's proper 2 years, 2 years and 2 months of data.
okay.
so
So
it has more data points and more repeats. Also,
yeah, because I've been running just for 1 year, and now I've just like I mean for the test I've been just using like 1 year, but now for the final one I've done the entire time series, and I've done more repeats because I think that for the test I was using just 5 repeats, and now I launched it with 64.
How many runs is it in total, Anna?
It's about let me
I think it's
2000.
I think it was about,
Yeah.
no, it was more than that, wasn't it?
Oh, wait, let me.
I've got a number of 53,000 in my head or something silly.
Yeah.
It's
Yeah,
something like 53. I checked this morning.
Yeah.
It's on 3,000 something.
Yeah, I think it's not faster. I you know, I ran it in my personal computer as well. It doesn't look faster. So we can come back later about this issue with Francesco. I
Yeah.
think I'll join like maybe.
Is that tough ICSM data? Or is
No, it's a queue.
The QACSM.
It's only up to 100. So
Yeah.
I'm not sure what happened.
yeah. That's, I mean, if it takes so long, then it's really, I mean, we have been discussing it before. I mean, trying to reduce it with the dimension. Because, I mean, you don't need all information of the, in theory, of the ACSM to have a proper.
Yeah, I think they have simplified.
Yeah,
as much as possible already.
Okay.
Yeah, I've blacklist. Yeah, 5 or 6 MZs. Yeah.
Yeah. Okay.
And if I may, those of you who haven't responded to the eCost invitation, please do so. The ones you're here, because I'm seeing Andre, Anna, Fon, David, Anya that didn't accept. So please do so. Even if it's online, Cost asks us to keep a record of the meeting so that we are able to justify that we reach the objectives in the end. Okay.
Okay, so the emails that, I mean, I've got like a bunch of different emails from last week, from previous workshops. So I wasn't.
Yes, because we are recording those as well. So I sent a general email to you explaining, but maybe it got.
I did, but I accepted those.
I accepted it as well.
Maybe you didn't accept the one from today.
Oh no, the one from today, that's true. Probably not that.
Or that's
what I did all the old ones.
Okay. So just in the coffee break, I may remind again.
Okay.
Maybe we should start. I will. So just let you guys know this meeting is online, on live, as well as recorded. So I think it's a it's a protocol you need to tell you guys. So maybe we can start. So I think this is what we progressed on in last workshop, basically last December. We still have quite a bit red and green as well, and yellow as well, but now it's really, I think it's really impressive. Most of the data managed to have at least half the rolling results already, but just need to be refined. So I think only the Pewter Dome, London, and Birkenist happens, and also Axel in Lund. Those data sets, I haven't seen it. I mean, I didn't get the rolling results yet. But I think for Birkenist, Stefan already has started to run the rolling, but I think it's not finished. So he will give a quick update today. And for UK, we have, for the London data, we have just talked about it. I think the rolling is not finished. I thought it could be finished, but it's not. And the Paris one, I think previously Laila and Sean would constrain I think Sally's BBOA for run the rolling, so they want to change the BBOA constraint. So it might take maybe another 10 days for this result. And for the Pewter Dome, as far as I know, I think Evelyn told me she will have some rolling results, but I'm not sure when, well, if they're ready. So for the Zeppelin data, I think I will not include it in this study because I personally also don't have much time. I attempt to analyze it using the latest software to analyze it, but however, somehow I get a negative error matrix, so I cannot run the PMF at the moment yet. So I guess I will not include this for this overview project. So for the Zurich data, I think I have some rolling results already, but I'm trying to constrain the cigarette factor, maybe to get the more for the rolling. So that's what I'm trying, and the rolling with the cigarette factor is still running. So maybe need 2 weeks or so. But I think this looks very promising. And yeah, so I guess, okay, wait. So this is the plans. I think we kept most of the promises, like maybe not okay. Today we want to finalize the figures and outlines. So I have plotted a lot of figures you have just suggested during last workshop. So hopefully we can look at it and see some interesting stuff, and then we can at least finalize what figures we want to include it in this study. And I know our cost action has been extended, but I think we still want to, keep the deadline to submit by the end of March. Basically 1 month to go, but maybe it's still quite tight, I guess. But I think we are close. So, any questions? Any comments? That's the update from my side. No?
I guess everyone is happy when we also get this done now. So
Yeah.
I think it's great.
Yeah, we're waiting for the draft. Thanks for the hard work.
Thanks. Yes. I think what else we should mention? I'm not sure if Benjamin's here actually, but well, if he's not here, I will ask in about maybe because in Marseille, that's the only data did the paper correction. Maybe but like I think Jenny from Romania tried before to test the differences of PMF by including the paper correction and without including it. It doesn't change much. That's
Yes,
yes.
we tried, but only for 1 month.
Okay.
At the beginning, when we discussed a little bit about this, me and Axel, I think we tried for 1 month of data at some point, but it was only an exercise.
Yeah. But I mean, at least during that month, it doesn't see much difference. But I'm just wondering how. I haven't looked into the details, but how was the OOA factors, affected by this paper correction?
Sorry, I think we just had a look on F43 and 44, and now we know that we didn't had the most correct way to calculate it at that time. So I don't know to answer. So it wasn't so much difference between these two MZ in the profiles at the end, as far as I remember.
Yeah, well, it'd be great if you can look into maybe just a little bit to see if because now the 44, 43 plot, the calculation changed, so it might change as well. So I guess maybe it's worthwhile to revisit to just understand a bit what the paper correction will affect the OOAs, I guess. So,
well, I think this is, very individual from side to side, and it's just, I think some of the last intercomp in Paris just showed that you can just overcorrect, right? And then you really have, then the mass spectra obviously can look strange, or not, or really strongly influenced. But that might depend on the period, the station, the status of your instrument, and so on. So I think it's very very hard to tell. But as we don't have an ideal way to correct for it, it's probably better to try to not use it now consistently, and then. But it's still the question if you want to mention kind of the degree of, for those that where one can where one can where it was measured. I mean, how much 44 one had during the ammonium nitrate calibration. So, or I don't know what you had in mind, how to discuss this in the paper. But I mean, it might be worthwhile to I mean, have in the supplementary something. I mean, but I don't know how much is available.
Yeah. But like, I think we can mention that what Jenny did test, and also mention what the intercomparison did in Paris. So then we can say we decide not to correct it because it could be more wrong than more correct. I think that's that's what we can say, right?
Well, you could still say more if you want. I mean, you could still say, I mean, how much is in during the calibration the 44 artifact, and then you could also give the range of how much nitrate you have at that site, I mean, in a relative fraction. That gives you at least the idea, I mean, how much the correction would be in 444. But I don't know. I don't know how much information we have. If you have it only for very, very few sites, then it's not. Then it's also not giving a good impression. It would be good to have it in as complete as possible. But I don't know how that's feasible or not.
Yeah, I think maybe this could be another paper. Yeah, and also the other thing is not everyone did I think back then some people did jump scan calibration.
Yeah, that's the issue.
Also, so we cannot like provide a complete story, and also I mean the P-break correction you cannot like correct it afterwards. So that's also a problem. I think we didn't do it in the very beginning. Yeah, so we'll see. I mean, I will contact Benjamin. Maybe he has something. I mean, at least he can convince me why he did it. Then, yeah, we can. I will talk to you guys later. Yeah, so I guess we have to move on. Let's see, the next speaker will be Samira.
Yes.
You want to share your screen?
Yes, I can. So can you see the screen?
Yes.
Okay. Good morning, everybody. I'm Samira, and I'd like to take this opportunity to talk about source apportionment analysis on ACSM datasets from the Tropos Research Station Milpids. And the research station Milpids is operated by the Leibniz Institute of Tropospheric Research. The Milpids site is a rural background site located in Germany near the city of Turkova, 50 kilometers to the northeast of Leipzig. The measuring field is situated on a flat meadow surrounded by agricultural land, and the ACSM has been permanently operated at the Milpids since June 2012. First, I'm going to present short overview. What is done is seasonal PMF runs for each season for 1 year, and from those runs, we found that we can have 5-factor solution for all seasons, which 3 of them are identified as primary organic aerosol. It means that HOA, BBOA, CCOA, and 2 of them are identified as secondary organic aerosol, including SV and LV. And also, we had rolling PMF runs for 1 year, season by season, but from last workshop, we remembered that it was difficult to separate 2 secondary organic aerosol from each other in winter time. And now, what is still need to be done, so is to find a way to separate 2 OAs for winter and run 1 year full in coordination with the European overview paper from PSI. And in the end, working on complete ACSM dataset at these 5 years to do long time source apportionment. What I want to present today is rolling result of 1 year. So time period for data is from September 2016 until September 2017. In this rolling PMF, I constrained primary organic factors. I used HOA from CRIPA, BBOA from SALI, and I generated CCOA from our own data and used it by selecting a random A value from 0 to 0.3 for HOA and from 0 to 0.4 for BBOA and CCOA, and also with bootstrap approach with 14-day window and 1-day shift with 100 repeats. Then in criteria part, I applied correlation between NOx and factor 1, levoleucazan with factor 2, also explore variation of M/Z60 and 115 for factor 2 and factor 3 respectively, black carbon with our primary factors, and in the end I used sorting M/Z43 and 44 for our secondary organic factors. So here in the top part of the screen, there are the bootstrap results. And in below, you can see the rolling PMF result for winter. We have the left-hand side plot from last workshop, which I already said that I couldn't separate 2 OAs. They had similar pattern in time series and mass spectra, but in the right-hand side, as you can see, there is our new results, which 2 OAs are really well separated, even it's clear from our diurnal profile. We have some differences in also in mass spectra and time series as well, this decreasing and increasing during the time. Actually, the problem was with p-value section in SOFI in criteria panel. It did not work for 2 of my criteria, and I think maybe it can be important for other SOFI users to check if their p-values were probably working for their PMF runs or not, because it affects the results a lot. And here just is a quick comparison between bootstrap and rolling. The rolling result is shown with colorful lines, and the result of bootstrap is blue one. And with this comparison, yes, now we got pretty good results in rolling part. Of course, there's some differences in some points, but it cannot be a problem for sure because of this rolling and shifting windows part. And here, now I'm going to show you the new rolling result with latest SOFI version for 1 full year. As I already mentioned, I constrained first 3 factors as HOA, BBOA, and CCOA. So in mass spectral plot, you can see them. And the last 2 of them are our OA factors as SV and LV. But in this part, you also can see the time series profile for this time, I mean for 1 year, and the bar graph of contribution based on monthly resolution. But what is important here is very unique pattern for each factor and each source. Well, here you can see the contribution of each factor in pie chart plot. They also give us some information about our sources, like winter has the highest CCOA and BBOA, and about the secondary organic aerosol and sources, we have some trajectory plots which show us they are probably coming from the east part of country, and to make sure about this, it needs to have a deep look on trajectory plots. And at the end, they are the fraction between M over Z 44 and 43. There looks good just in winter case. There's some points are noisy, which maybe belong to an event, and I'm trying to find that which event could be to describe these inner plots here. And for this part, summary and outlook, differences between these two is splitting from bootstrap and rolling for winter time has been solved. And beside each season run, one full year rolling is done and is in good agreement with seasonal. And I think now it's ready for the overview paper. And for the next step, I want to do this PMF and rolling and also seasonal for this long time period as a long time source apportionment. And this is all, and thanks for your attention. If you have any comments or opinion or idea about each part, you're very welcome.
Hi, Samira. I'm Marta. I wanted to ask you, what did you compare to say that seasonal and rolling results are in a good agreement?
Yes, this is just the example for winter time, but for also for other season, it's again in good agreement. The bootstrap and I mean the seasonal and rolling. Even seasonal, I did the rolling for each season separately, and I did for fully 1 year in one file PMF run, and all of them are in good agreement with each other.
Perfect, thank you.
So this p-value issue that you mentioned, I mean, are you saying the p-value is calculated wrongly, or one needs to adjust it, or I didn't 100%?
In the last SOFI version, p-value did not work for these two parts for explore variation for this criteria. I don't know why, but in latest SOFI, I found that it works and it improves the results.
What means it works? It crashed before, or what does it mean?
I think it's just not keeping in a herd of value, actually. I mean, like, even though she checked the tick box, it just didn't,
it didn't
give the answer. I mean, the values at all. So that's why. And I think she ended up select basically everything. That's what happened.
Okay. Okay, but that's solved now. That's great.
Yeah.
So the 44-43 plot, was that now already with the new calculation or not?
Yes, new calculation.
Can you show it one more time? It was a bit fast.
You meant this plot, right?
Yeah.
Yeah.
It's still surprisingly high to me, 44. So.
Yeah, but like, I think it's because the residual. So if you look at the equation, in the denominator there will be all the residuals of the OA, In the numerator, it will be just the residual of 44. So because you might have some negative residual for some of variables, and you could make the denominator smaller. So
wait a minute.
Yeah.
Say it again. So did I miss something?
So the equation of, for example, if you calculate the A44, so in the numerator will be the the signal, the mass concentration of A40 MZ44 from the OOA plus the residual of 44. That's the numerator, and the denominator will be the residual of the OA, basically all the factors, plus the OOA concentrations. So in this total residual, because you basically add all the variables residual together, so some of the variable could be negative. So that's why it could be make the new denominator smaller. So it's still, I think the problem is mostly is solved, but the noisy points, I think it's okay. And also normally those noisy points are low concentration points. So if Samira, you can, for example, color code by the OA mass concentration, then this problem will be less critical. But this one, also for the 44-43 plot, in my opinion, the clouds of the points doesn't necessarily reflect what the sources is affected either anthropogenic or biogenic. It's not. I think it's not true. Like the assumption you have for this plot is your OA factors are dominated by 44 and 43. So if you have something kick in the LO especially, so it could move the clouds quite a bit. So it's not necessarily be anthropogenic if it's within the triangle.
Well, I don't know. Well, at least the previous work indicated that, if you have biomass burning SOA, then you have then it seems like you have less 43 in comparison to 44. So you're more on the left-hand side of the triangle. You have that a little bit in this December, January, February. There's some points up there.
Yes, it's true. It's like if you have people biomass burning.
The tendency is okay. Yeah. I'm just thinking if how one eventually wants to present it also then in the overview paper. Do you think it? If one neglects the low concentrations, you've just cut out, for example, the lowest 10 percentiles of the concentrations, will it help to make the plots cleaner?
Yeah. The cloud.
Maybe you should do something like that then. Because they're a little bit disturbing, right? All this. Some of the things that are just due, as you said, due to the very low concentrations. So maybe if you want to really compare or put in a supplement, maybe we should even remove the lowest concentrations. Yeah.
Okay.
Anyway, this looks good.
Yeah. Thanks. You should move on.
Should I stop sharing, right?
Yes, please. I think next is Anna.
Yeah. I share my screen. So can you see it?
Yes, but maybe you need to swap the screen. You know, in a laptop, on the right, display setting. Yes. There it is.
Okay. So yeah, I'm going to present the updates for the rolling results for North Kensington in London. Just as a quick reminder, so North Kensington is it's a urban background in central London, and we have QACSM measurements from January 2016 to February 2018, and we have collocated gas measurements and as well black carbon measurements. So, well, that's just as a summary from the seasonal analysis. So we ran seasonal analysis for one of the years from end of 2016 to February 2018. And we use the CRIPA profiles for HOA and the cooking aerosol. And we constrain with our BBOA factor for wood burning, and with bootstrap and bootstrap and 100 repeats. And just like there were depending on the season, there were two OA factors, and especially in the spring and summertime they could be the more oxidized and the less oxidized factors. They could be properly separated. But the second OA factor is dependent on the winter and the autumn, so they could not properly be separated in the seasonal analysis. And on one of the winters, we could observe one HBBOA or one SOA boot burning related. So that was kind of like being a bit challenging in the sense that, I mean, for the rolling, how to separate the seasons for the two OA with seasons with two OA factors or just one. From the last workshop, there was this suggestion to try to rolling for one of the seasons that they had that only 4 factors were observed, and compare the 4-factor solution and the 5-factor solution. And so for that, I've done that for the winter 2017 and 18, and using the same profiles to constrain as for the seasonal, and just had like a kind of a quick run with 5 repeats with bootstrapping and using 14 days window on 1 day shift, and using the same criteria as I was using for the seasonal solutions. And so those will be the profiles for the 4-factor solution and the 5-factor solution for that winter. So the 4-factor solution, it returned like kind of a good OA factor, but when we were splitting with the two OA factors, there was appearing this 37, MZ37. 37 was quite prominent in the LOA factor. So moving on, so I tried to run the same 5-factor solution with MZ37. So here, so we don't have the 37 so prominent. Well, it's not there in the factor profile, but then we had this this concern that maybe like this all OA factor was quite driven by MZ29, that it might be some interference with air. So another step forward was just try to downweight MZ29. So for downweighting, meaning just like taking the noise, the signal to noise ratio from MZ29 and set that a threshold to separate weak or bad solutions. So And this is the profile for that one. But still, like 29 was not so prominent in the factor anymore. But still, like the separation of the two OA factors was not so good. I mean, the large MZs in the LOA factor were not so. I mean, were quite similar compared to the more oxidized factor. So decided to move and try to remove it as well, the 29. And in this case, I think that the separation between the two OA factors was better. So we had a more oxidized one with a lot of like 44, as it should, and then we have the less oxidized one with lots of 44, but higher 43 fraction compared to the more oxidized one, and as well, like the less oxidized one had larger MZs in their profile comparison. That will be the uncertainty calculations for the different factors, and for the primaries, the HOA, BBOA, and the cooking aerosol. So they were quite good with quite low error or uncertainty estimations, less than 12%. And well, I mean, the spread for the two OA factors were, I mean, they were quite good, but maybe like the slopes, they were quite high. I think that that's kind of expected for the secondary organics. So that will be the time series and the diurnals for the different factors, and that will be for that winter in 2017 and 18. And so the diurnals, they look quite good, and the two OA factors, I mean, they're quite similar, but still you can see that there's some differences in the two OA factors. And that will be the F44 versus F43. And well, I mean, I think that the separation of the two factors, I mean, it's very tight, but still, like, we could distinguish like the two factors, and the distribution of the points in the F44-43 space. It's quite reasonable. So we decided to take this configuration to run for the entire time series from 2016 to February 2018, and as well just try to run it quickly with just 5 repeats and without the MZ 37 and 29, and that will be the factor profile. So those will be the primary ones and the two oxidized ones. So there's a good they look as, I mean, they could look quite similar, but still with some differences, and the uncertainties for the different factors, for the rolling for the 2 years, more than 2 years of data. I mean, if we look at the uncertainty, they are quite high, about 40-50% for the BBOA and 35% for the cooking. But I think that that's quite, like, for the long-term run, I mean, that's quite expected. And for the OA factor, like, the error estimation is about 34%. And that will be the time series for the different factors. And so we can see here, like, the two OA factors, they are quite different. Well, there are some differences in there, so we are quite confident that that now maybe they are good, well separated. And that will be like the diurnal, so the HOA factor with distinctive, like, 2 peaks during the day, the BBOA with just like a peak in the evening. The peak at the lunchtime is more diffuse for the cooking, but I mean, those were the ones selected with a lunch peak properly, and the 2 OA factors. That will be the separation. The F44 versus F43 plots for the different seasons. So that will be the winter ones, so the spring ones, the summer, and the autumn ones. And well, the points, they are most of them within the triangle, so that's quite good, I guess. And and that will be the correlation matrix for the different factors with the different from the different externals. And so, as expected, the HOA factor correlates well with NOx and the total black carbon, and the BBOA correlates well with the wood burning, with the BC wood burning, and the more oxidized one is the one that correlates better with nitrate. That will be the contribution for the different factors. So that will be for the entire time series. So yeah, almost more than half of the organic aerosol is explained by the 2 OA factors, and we have like the rest is explained by with the primary ones, and that will be the seasonal variation for the different factors. And well, we can see like maybe the color scheme is not so good, but yeah, just we can see that the total organic, the oxidized ones, the contribution is higher during May and June, and then slowly decrease even in summer and towards the winter. So the next step, so I'm currently running and rolling from the tire time series, but also we've removed the 15 because I mean it's not giving more information, the 29 and the 37. So now I'm including more repeats because so far the data that I'm just showing is just with 5 repeats, and so it's taken a long time. So there's about 53,000 runs to be done, and yesterday when we check, I mean it was still at 28,000. So I guess that it's going to, I mean it's almost halfway, so I guess that it's going to take like 7 more days to complete and so that will be me for now, and if you have any questions I will take it. And obviously thanks to Ian a lot because he's been great, like following and suggesting what to do next and so on.
Thank you. So I don't remember about the first A44-43 plot. You go there.
This one.
Yeah, this one is not the one corrected yet, right?
I have to double check.
Okay.
I have to double check.
Because there is quite a bit of data, like really high.
Yeah.
Sure.
I have to double check. I'm not sure because I've replotted some of the graphs yesterday, but I'm not really sure if that one was already calculated. Yeah, probably you're right. That's an old one. Yeah.
I see.
I have two small questions, comments. I mean, one question is, I mean, it's just a detail, but you compared the BBA in the correlation matrix with BC wood burning and the traffic with total BC. BC traffic didn't work, or are you?
Well, it's I didn't use it as a criteria at all. I just used NOx HOA to correlate with NOx, but it appears, that the
I was just wondering why you didn't use BC traffic instead of BC.
Well, I don't have like a proper explanation for that. I think that I just use total BC, but I can try to see if it correlates. I mean, it has to correlate better with BC traffic.
Yeah, if it correlates even better, then I would use traffic.
Yeah, so I can add that.
I mean, another question is, I mean, do we have actually now many data sets where we kind of remove 29 or other MZs that are quite prominent in the mass contribution? But I mean, the question might be how we deal with that. I mean, should we then at the end report? I mean, what the fraction of mass is that we're missing by removing those MZs, or should we? I mean, we could also think about that one kind of puts it back to the profile by doing a multilinear regression. Just saying, yeah, that, I mean, roughly that's the contribution to kind of make it comparable to the other sites, or I don't know. I mean, it's a little bit the question, yeah, because I mean, some sites will then have 29 and some not, and 29 is okay. It's not okay. On the total mass might not matter that much, but it will maybe look sometimes a bit. His mass spectra will look a bit different.
Yeah.
So I don't know. Ian, have you thought about this? How to deal with that?
Yeah. I don't know how to back calculate or to insert this part of mass back. So as far as I know now, in a doubling or a cancel point, the one of those two sites are excluded the 29 as well. But others are rather okay. I think also Axel has the same problem. I'm not sure what's the progress of his. I also asked people from Paradigm, they were saying, first thing you can try is the downweighted. If downweight doesn't help, then blacklist it. I mean, but yeah.
Yeah, at least we need to report what is the missing.
Yeah.
I mean, how much mass was in
but
those lines that were removed.
How exactly we can do that? You mean the multilinear regression or?
Well, the multilinear regression, I mean, it's just an idea. I mean, in theory, you could just I mean, at least for the average profiles, you could just make a multilinear regression and then in theory put it back as a best estimate. But I'm not sure if that's. I mean, it depends if there's really if the air makes a big difference, then obviously that matters. But that might come out as should actually then come out as a how do you say? I mean, an offset in the multilinear regression, right? I mean that if the air makes a difference, that doesn't have a lot of time dependence. So that should be then an offset, and that shouldn't influence, in theory, the.
It's not the case though. Like, I think if you go and plot this 29 versus 43, you are always being very noisy, and you have like really wide range of positive and negative intercept.
Okay.
So, but some people just got lucky. They didn't see this 29 in their profile. Nothing strange happened. But somebody will be not that lucky, then it will, affect quite a bit their PMF solution. So I think.
Anyway, those that removed it could try to do a multilinear regression on 29 with the sources to see if it could make sense. So then one could report it a bit, because then the total mass would be more comparable. But otherwise, I would just report in the supplementary somewhere if some masses were blacklisted and how much the fraction of the mass was that one neglected. It's a little bit of detail, but I don't know. At the end, if you want to say we are consistent, right, then it's always a question. What means consistent?
Yeah. But like, I think if you guys want to publish your own data set, I think you can discuss in yourself. I will just refer it. If there are too many special cases. Yeah, well, I think also, yeah, I
Well,
mean, like,
or as
yeah.
was Andre was suggesting, maybe I mean, I guess that the groups that we have these special cases that we have removed some of the MZs, we can try this multilinear regression. And even if it's in the supplementary of this paper, because by the time that if we publish our data sets, I mean, I'm not properly sure that it's going to be aligned in time with this publication anyway. So,
Yeah.
I mean, I think that maybe that's something that we, yeah, each individual group that we have these special cases, we can just try and just.
Sure. Yeah, well, let you guys know. Okay, so maybe, thank you, Anna.
Yeah, thanks.
Well, to Hasna.
Yes.
Yeah.
Okay. No. Okay. You can see my screen?
Yes.
Okay, good. So, good morning, everyone. This is Hasna, and I will present to you the social portion analysis on SSM data from Lille. So last time I present to you the bootstrap seasonal solutions. Today I want to present the rolling PMF results with 4 factors, 2 primary and 2 secondary factors. So first of all, I would like to present the site, which is an urban background site located at the campus of the University of Lille, roughly 4 kilometers from Lille's downtown. We worked on SSM measurements, which is still operational until now, but for this study, we focused only on the period from October 2016 to August 2017. We have also the data from additional instruments for in situ aerosols, etalometer and nephelometer for the measurement of light absorption and scattering of atmospheric particles, and SMPS for particle size. For etalometer allows us to estimate the black carbon concentrations and also to distinguish between the 2 main sources of black carbon, which are the fossil fuel and wood burning. So in this rolling PMF, I constrained the primary factors HOA and BBOA from my winter obtained from my seasonal results by selecting the random e-value from 0 to 0.4 with the bootstrap approach, and for 14-day windows when they shift with 100 repeats. For the criteria, I applied correlation between BC fossil fuel with HOA and explained variations of MZ60 for the BBOA, and we used this sorting for secondary factors based on A44 and A43. So this is there are the results for our rolling PMF. Here present the profile factors with their diurnal cycles. As we see, we constrain the primary organic aerosols, HOA and BBOA, and they have averaged e-values of 0.204 for HOA and 0.2 for BBOA. And we say, and for the 2 secondary OA, we say a better separation between the 2 factors. On the right graph, we the primary organic aerosols show distinct diurnal patterns for HOA with 2 peaks, one in the morning and another in the evening. For BBOA with strong nighttime maxima, while for the secondary organic aerosols are rather stable. Here I present the corresponding time series on the left with the fractions for each month on the right graph. We say that for MOA present a strong temporal variations comparing to the LOA. For the BBOA is in summer is lower. On the error estimations, we estimated uncertainty of HOA factors using the slope of the linear fit of standard deviation versus the average mass concentrations. Here we have higher errors for MO and LOA and smaller for the others. But if we say for HOA, we have it looks more scattered than the LOA. So, but if we say the slope of HOA is just 14%. Here I present the contributions of factors for the whole year and for different seasons. As we say, the primary traffic related HOA had a little variation, seasonal average between 11 and 14% throughout the year, while for BBOA, it showed a distinct yearly cycle between 8 and 17%, increased in winter to 17.7%, with a yearly average contributions of 14.5%. For the 2OA, the contributions don't vary distinctly over the season. On the right side, we have the correlations between factors and externals. So for HOA and BBOA show a good correlation with BC fossil fuel and BC wood burning, respectively. Here I present the OOA F44 versus F43 analysis. After subtraction, the F44 and F43 contribute from primary factors. We present the F44 and F43 for each season and for the whole year on the right side. And as we say that we have a good separations between MO and LOO, and I think that it's look good for each season. At the end, I analyzed the ASSM data using Super Pro. I did the seasonal PMF and rolling PMF over 1 year with Bootstrap, and for 4 factor solutions, 2 primary HOA and BBOA, and 2 secondary factors. For the next step, I will compare it between the Bootstrap seasonal solutions and rolling PMF. I already began, but I didn't finish. And also, I will complete the SSM dataset for at least 5 years for the list sites. And that's all for today. Thank you for your attention.
Thank you, Asna. Yeah, I don't have many questions since we have many discussions already.
Yes, thanks, Ian, for your follow-up and your support.
Yeah, you're welcome.
I have a general question. Yeah, maybe one on this one as well, but first the general one. I mean, so in Lille you are in the city center, or?
Yes, we are it's near to the Lille center, and it's affected by traffic, especially because it is around the University of Lille campus.
There's no sign of cooking. I'm just wondering.
No, because there is some restaurants, but it's not just some university restaurants. but I no for the cooking I already look for this factor, but I didn't find something for cooking.
Yes, if I can add something, it's just it's surrounded by residential areas, and people are not coming back home in midday.
Yeah, restaurants help usually to see it better. I guess if there's not many restaurants.
No, there are like 3 restaurants on the university campus.
Yes.
And not so many in the surroundings.
Yeah, but I was just thinking about it also when I saw this 2. I mean, when you showed this uncertainty in the HOA.
Yeah.
Contribution there. I mean, I don't know if you want to check at least for those periods where you were really different there, for example, on the top. I don't know if during those times we actually, I don't know, the mass spectra or something is special somehow. I mean, all the stuff that is
just discussed that with
a special event or something.
Yes, it was in this period.
Just this peak that brings these all these.
Okay. I see. Did you try to see where the air mass? I mean, could that be some special air mass from somewhere, or you didn't? It's not clear.
Not yet.
Not yet.
Yeah, it might be I mean, might be just a special event where you have an additional source or something. Yeah. Might be worthwhile to have a look, but it's, I guess, for the whole data set, it's a detail.
Okay.
I guess it looks good. It's good that you catched up.
Thanks.
It's very impressive. So maybe for this scatter plot, the arrow estimation.
Okay.
And maybe you can try color code by temperature or date and time, just to see if there are any tendency for those parameters. For example, also you can for your LOA you have like another slope as well. So those things you can, I mean, it's probably the points underneath of the one-to-one line, and not the one-to-one, but maybe the trend line are at the same time with the one on the left of the trend line of the MOA, I guess. Then in the end, when you add the L and MO together, it agree with, well, again, that's probably the Y, but maybe if you can color code by date and time, then it will be more obvious.
Okay. Okay, I will check it for it.
So is this local time or UTC?
Local time.
So Ian, for this uncertainties at the end, do you think you wanna? How do you want to present it? Just provide average numbers for each site, maybe, or you want to separate it for seasons, or what? I think it's. I think these are interesting numbers, but it's a question how to present.
Yeah.
I mean, it's something we always advertise also, that if you include the bootstrap and do that with Software Pro, that you kind of get an estimate of the uncertainties. So it's surely, we surely should discuss it. It's a question how much detail you want to give.
Or is that sufficient, you think? You provide a table for all the data sets. I mean,
yeah, probably.
It doesn't make sense for me to average it, though. Like, so, like, for example, when we do index plot, we basically assume the mass concentration of this factor has nothing to do with your arrow, basically with the slope. So, but that's probably not the truth all the time. Yeah, but like I think.
It's different. I mean, some data sets probably have a problem at low end. Here it's this special event that probably sticks out there. I mean, I would really look at this special event. I mean, there maybe some stuff also in the residual, and that's maybe an interesting event where maybe you just, I don't know, maybe you had fireworks, or maybe you had, I don't know what, a building was burning down, or shipping emissions somewhere. I don't know. I mean, something really different in that period for this data set. I mean, other data sets, it's again different stories about how the error is changing as a function of time or concentration and so on. I don't know. I mean, at least we should report some of those average numbers in the table. And
yeah. Yeah, good. Does anyone still have questions? If not, we can have a coffee break, and then we come back at 11:20, followed by Stefan's talk. Yeah. See you later. Thank you very much. Hello.
Hi.
Hi.
Hello.
So shall we start? Stefan, are you here?
Can you hear me?
Yes.
Excellent. Good morning, everyone. I hope you are all well. I will turn on the shared screen one moment.
Yeah.
Can you see that?
Yes.
PowerPoint presentation. Okay, excellent. Full screen. Okay, so I said I would give a very brief update of the Birkenes data set today. And this is for the years 2016 to 2018. So as a reminder, Birkenes is a site in the south of Norway that's a regional background site. It's very clean and slightly maritime, and with some episodes from Eastern Europe. And as you will remember from last time, the key to success for doing PMF is to do a 4-hour averaging time and to reduce the weak variable threshold to 1.8. And so using that, last time I found for the wintertime 3 factors, which was done by constraining factor 1 to the HOA average reference profile and BBOA to a BBOA average profile, and using the p-value as a criteria, which actually left most runs then for the average that you see in this panel. Yeah, so in the end that looked actually pretty reasonable for the winter season. But then I applied the winter profile as a constraint to the summer, and this again with Bootstrap, and we did find 3 factors, but actually it had quite a high MZ44, and another unfortunate issue was that there's not really an external data set available to compare it to. So when I then constrained that summer profile and did a Bootstrap analysis of that, I found that the MZ44 was in fact even higher, even though, I mean, the rest of the factor looked fairly reasonable in that it was a low BBOA contribution, and the HOA and the OOA looked okay. So last time, and the suggestion during the last meeting was to, instead of constraining now to the winter factor, was to instead constrain the BBOA to the BBOA average reference profile. And so this is the update that I have for you today. And when I do that, it reduces the MZ44, which is good. I suppose it could have increased all the other masses to get the same relative profile, even if that was unlikely. And so reducing MZ44 actually gives a lower BBOA fraction in summer than we had previously. So now it's about a 6 to 7% BBOA contribution. And based on that, I had a brief email with Ian, and we decided to run the rolling PMF using the BBOA average as the factor 2 reference profile. Yeah, and this was just the comparison I had of the winter and summer, which was that as expected and as is reasonable, the OOA is dominant in summer, or dominant in both winter and summer, but is much higher in summer with a lower contribution of HOA and BBOA in summer as well. Yeah, so we've got 3 factor solutions for Birkenes in summer and winter, with OOA as dominant fraction, significant HOA and BBOA in winter, somewhat lower in summer. And the rolling PMF is done, actually. Main problem now is the import and analysis of the runs, which is taking longer than expected. It's actually saying it will take like 2 days. So that's where we're at. And thanks to Ian for his input. Yeah, so that's what I had.
Thank you, Stefan.
Can you remind me, Stephen? I mean,
yeah.
So more than one O factor doesn't make sense in all seasons, or?
So I compared it in both winter and summer, and I could try and bring up, but in the previous presentation I showed a slide where I had, it was the correlation between an OOA1 and an OOA2 was amazing. So it was like an R squared is 0.99, which basically means they're not different.
Okay.
So there's no added information.
Yeah, I didn't remember. Thanks.
Stefan, what's the, I don't remember what's the time, what's the timestamp of you analyzed for your data?
It was 4-hour averaging.
I mean, for how long? Like.
So it's 2016, 17, 18. So we have 3 years of data. And I've run the rolling PMF as suggested. So it was 14-day window, 1-day shift.
Okay.
That gave about, I think it was like 40,000 runs or so. So yeah.
It's up to 120 120 MZs.
Yeah, it's up to 100, I believe.
I see.
Well, we should be able to see in the, I plotted up there, it's 100.
Yeah. So the rolling has been finished.
Yeah, the main issue is that it takes several days, obviously, to run it. And oftentimes when I log on to the NILU server, I'm forced to do an update. So I have to stop. It tells me your computer will shut down in 5 hours. And so I have and nothing I can do. That would be a good functionality, by the way, to have. Like if there was somehow an interrupted run, is to be able to start it from a certain window might help or so. But anyway.
Yeah. I think the averaging or evaluative criteria is always, need the continuous running. Only in the PMF can be resumed.
Yeah, in the PMF, yeah. So that's when I got I did about 2 days of analysis, and then it was 2 days into about a week of PMF, and yeah, that's when it got stopped. So that caused me some delay. So and I figured, I mean, I could have worked it out. I mean, you could go in and you could cut the time series down, and you could then try to work out where I should start from, and so on. But in the end, I just restarted. But if there was this option to see how far it had got and then start, I could have saved those 2 days again,
Yeah. Okay.
But maybe it's only me that has these kind of issues. I don't know.
It's not just you. Okay, so maybe we can move on to the next.
I'll just stop sharing.
Yeah. Marta will talk about the progress of the rolling versus seasonal.
Can you see it properly?
Yes.
Good. Well, so, well, I am Marta, and I've been recently working on this comparison of the rolling versus the seasonal, as it came up in the last meetings, and we commented that it was the approach I had taken, maybe it wasn't the fairest with both methods. So we are trying to tackle this issue in a more systematic way here. I've been doing this work with Ian and with Francesco. The objectives of this study are to characterize the rolling and seasonal differences or consistencies regarding specific events, maybe some locations or external provisions, etc., and conclude on which method performs better or is adapting better to reality. And the idea is to do the comparison of rolling and seasonal datasets with the same datasets that Ian is using for this overview paper, and decide on the best way of presenting these differences once they are characterized. The characterization of the differences must take into account the characteristics of each method, like the repeats performed for each PMF run, or the degrees of freedom of each way, or so, and other things. Now, in this presentation, I will show this preliminary analysis we did with Ian and Francesco with the Barcelona and Magadino datasets. Well, our papers will be released, I hope, in this 2021. And okay, I will start with the comparison of absolute and relative factors, as well as Samira. She did the same comparison. And in both cases, sorry, yeah, I'm showing the Barcelona dataset for the absolute concentrations of the fraction concentrations. I have 5 factors here: the COA, HOA, BBOA, less oxidized and more oxidized OOAs. And BBOA is only present in the coldest season. If we take a look at these graphs, it's rolling on red and seasonal on blue. And we see that the higher differences happen for BBOA and less oxidized OOA, although also in the more oxidized OOA. Similarly, as it happens in the Magadino dataset, in which the differences are higher for the OOAs and also BBOA. In the case of Magadino dataset, we don't have COA, but a local fracture appearing from the summer on, I think. And okay, so what we plotted here is a rolling R-squared and slope with a 14-day window, and this represents the time-dependent differences from rolling to seasonal. The X represents the seasonal and the Y represents the rolling. So if we take a look at the R-square, we see how in the primary factors the correlation between rolling and seasonal is quite good in a time series way, but it's not so good for the OOA. So one of them or both of them are varying in a way that doesn't go together. And if we take a look at the slopes, in all cases, sorry, not in all cases, but there seems to be an overestimation of the seasonal versus rolling in almost all of them, except for the more oxidized OOA in Barcelona and also in Magadino. Here I plotted the comparison of time-dependent profiles. This is the bootstrap profile for the seasonal approach and versus the time-dependent profiles in the rolling. So we find a very good agreement in both cases. So the factors are quite similar, unless for this winter, in which the less oxidized OOA varies quite a lot from the seasonal to the rolling spectra. If we take a look at the correlation with externals, we see that they are more or less the same in both cases, in both Barcelona and Magadino. The correlation with HOA versus black carbon fossil fuel and NOxes, it's very, very good. And we see maybe that the higher differences happen here in this period of comparison of BBOA versus black carbon wood burning. Maybe also here in these specific events, but they are not too alarming. Again, rolling is red and seasonal is blue, so we don't see that there is a clear winning method, as they are quite compensating all the time. If we take a look at the residuals of the key variables, which are calculated like the fraction of the ion I minus the modeled fraction of the ion I by the rolling or the seasonal, and we plot them in a histogram fashion, we see how we find these structures here for the F43, not for the F43, but yes, for the F44, F60, and F73, in which the seasonal is performing way worse for these ions, but this is not observed on the Magallanes dataset. And if we take a look at the total scale residuals, the wave that it's out from the overview plots in SOFI, and we plot it in the same way, in like time dependent, we observe that there is not a clear R-squared trend, but we see that slope is always below 1, which this should infer that the rolling performs with lower scale residuals in both Barcelona and Magallanes. And if we look at the same information but plotted in a histogram fashion, we see how whilst with the original resolution there is not much difference, as the errors can be attributed to noise. In a daily or weekly resolution, we can see how adapting are the differences, or we can differentiate if it's just noise or if it's actual differentiation of profiles or adaptation to the changes of the fingerprints. So we can say that all those shoulders differentiating from the Gaussian-like distribution can be attributed to systematic errors of seasonal or rolling methods. So we find this shoulder here, which is way higher than this one for the rolling. And in the case of Magallanes, it's even more obvious because we have this huge shoulder here for the rolling, for the seasonal approach, whilst the rolling error is sharper. Okay. And here we want to ask, well, about everything, but here especially we want to ask your opinion, because we found that if we wanted to compare the cues outcoming from the model, we had to renormalize them, taking into account the degrees of freedom and the number of repeats for each method. This is if the QX should usually be like the time points by the number of MZs minus the number of factors by n plus, sorry, I put a dot here, but it's a plus m, n plus m. This should be reformulated to this, but we have been trying different formula, but the last one we were most convinced of was this one, in which we take into account the number of repeats of each rolling run. This is due to the rolling and the shift of the rolling window. Each day is run 14 times, if I'm not wrong. and N to R, it's the number of date points of each specific window, which is 14 days long. And in the seasonal, we put this 5 here to take into account the number of seasons. And the idea was to perform a t-test, to, in case we want to reproduce these graphs for a lot of datasets, present just the result of the statistics of this test instead of the distributions. But it's still open. We don't have anything definitive. So any question or suggestion or doubt must be very helpful. Thank you.
Thank you.
Yeah, maybe a small comment first. Meaning this first graphs you showed, I mean, there I would also show it for the total OOA and not for the individual OOAs. I mean, the R squared or the...
You mean?
Yeah, like for those plots. I mean, you could also do it for the sum, no, of the OOAs.
Like here?
No, not before.
Okay.
Yeah, like those.
Okay.
Because, yeah, I mean, at the end, I mean, it depends who is interested in the results. But I mean, at the end, you could say the total OOA, we think it, I mean, represents mostly the SOA, and it doesn't matter so much the split. But I mean, the question is how good is the total OOA kind of represent? But that's one thing. Maybe we can go to the last plot one more time.
This one?
Yeah. So I'm just, shouldn't one be worried about these very low values now of Q to Q expect? Or, I mean, I don't know. I mean, before we also had deviations of 1, but I mean, they were not. I mean, now we're 10,000ths of the Q expected. So is something wrong with our calculation? Maybe still.
I think when you calculate the Q over Q EXP for one analysis, it's not. It should be the sum of all those values. So, I mean, individually, it looks very small. Then,
how is this? But the sum is still probably in the upper plot, still much lower than 1. Or am I wrong? No, well, I see what you mean. No, I actually don't. You say you should sum it up? You sure? No, why? Really?
like, I mean, here you should be, because each single points represent each here each bar right here just represent it shows all the data, all the Q the scale residual at each single point. So when you report one PMF runs, you should, sum them together.
Okay, I see.
You only one value. So here is just the distribution for all of them. Yeah, because we were just trying to find a more fair way to compare between seasonal and rolling. So we have to, dig into this QEXP value in order to make it more comparable.
So what is the interpretation of those two graphs now? One more time. Can you repeat?
Yes. Here the Q normalized in this way, in which we take into account the window repeats and the window length. So it's window wise, on the rolling, and on the seasonal it's season wise, where these 5 accounts for the 5 seasons used in both datasets. Correct me if I'm wrong, Gian, please.
Yeah, but what does the right-hand figure now tell us? So what does it mean?
Are you comparing the width of each of these
distributions?
Yes.
No, we were looking at the shift from the 0.
Maybe you should rather compare the area, the sum of the area of this distribution.
But that's the sum then again somehow. So but what does the shape tell us? Or what, I don't know. Is it telling us something about the quality, these 2 graphs? I'm not sure.
Yes, because if we find something like this, which is very small actually, shoulder implies that the error is not just a statistical error, which would be a Gaussian, but there's some systematic error here. Like it's not very clear in the QQX, but yes, in the scale residuals, if there's a system.
Yeah, the scale residuals, I understood it, but here, I don't know what it means. So you would then argue that rolling is doing a worse job because it has the shoulder, or what would you learn from this graph, or how would you describe it in a paper? I mean, how would you discuss it? So,
I think we were just trying to find a better way to compare the residuals. So I mean, if you just look at the scale residual, you will find the rolling always be better because mathematically you allowed more degree of freedom of the rolling approach, but not the seasonal. So we were just trying to normalize this degree of freedom to better compare. But this is, I think the shape doesn't suggest something, in my opinion, but just you can only compare the value in the end. This Q over QEXP right here is, I think it just, I mean, if you just plot the distribution, it will be similar with the distribution of the scale residual. So in my opinion, it doesn't show additional information except if you sum them up and compare this value to each other.
So what happens if you sum it up? Is it then different, or is it similar? Looks similar.
I haven't tried.
Well, in Magodino, maybe the rolling looks a bit better. Well, I'm not sure. No, the area is quite similar in both cases.
Yes.
So your argument is that the total sum of the Q over Q expect is actually similar. So if you would, it's like if you would do the seasonal with more factors or whatever, you'd also get.
Yeah, here is what we don't know yet. We don't know what to do about this. So,
yeah.
Because I mean, if you just simply compare the scale residual, then of course the reviewer will be, skeptical about, it's just mathematically advantage.
You could say instead of the seasonal, you could say you make just 2 week, not rolling. I mean overlapping rolling, but just you split the data in 2 week period, for example. Then you would probably also have an improvement, right? Yeah. I see what you mean, but at the end you're still representing the data better, right? Without having to. But you're saying it's logic that we do that because mathematically it makes, because we just
Yeah, but I mean, one could still argue is, even though it's mathematically an advantage, but it's still an advantage. So you can still enable your factor profile adapt to your temporal variations of sources, and still an advantage. But like how much we don't know. There's no way. Thinking there's really no way to quantify that.
Right.
Yeah. So we were. Sorry.
Yeah, I'm not sure about these some. Maybe I have another comment or a question. I mean, I'm wondering. I mean, I would have expected that the main differences, or a lot. I mean, would be in the periods where you have kind of. I mean, where you change the season, right? I mean, that there the differences might be the biggest. I'm not sure if you have any indication of that. I mean, are the residuals higher or something during the time period where you change from one season to the other?
No, this is not the case.
Okay. So this is just random anywhere.
Yeah.
Might still be good on the time plots if you show them. I mean, to show where you switch the scene. Have just a straight line that the one sees kind of when you. I'm not sure for Barcelona how you defined the season.
The season for Barcelona. Wait.
Anyway, whatever it was, but I think it's good to kind of put vertical lines just to see if there's any step or something happening around those changes from season to season.
The third season is September, October 2017. The winter season is from November to March included. So the end would be here, and April, May, and June, July, August for the summer, and September, October 2018.
I don't know. I mean, this graph I don't like so much because you don't see both colors.
Yeah.
Somehow. It's hard to tell. I mean,
Without the lines the next time.
Right.
I don't know, maybe we can see it better here.
Yeah, these are probably better. But your idea would be to try to do something like this for all or multiple data sets, is it?
Yeah.
Okay.
Yeah, Marta, I think maybe also was about to explain more how did you do this comparison, like here. I mean, the rolling is rather straightforward, just daily average. For the seasonal, maybe you could explain how we did it. Like you basically wrote a code or something, how to, yeah.
But in this graph, you mean?
Yeah, I mean, you mentioned, I think for the seasonal, for example, it's not simply just the time series from the seasonal. It's the so basically you consider your solution as also a rolling fashion. So you average your first 14 days as one point, one PMF run, or a bunch of time series in 14-day window. Then this 14-day window will shift over with a step of 1 day. Then in the second window, you will average this time series again. Then that's how you get the even for the seasonal time series.
Yes, I also plotted, because this is a start point. Okay, all the average of the 14-day window, it's set on the start date, and I have 1 point for each day. But I also tried to erase the days in which the transition of the rolling would be switching from one seasonal season and other, and the result was similar. I mean, it didn't make such a difference in the edges of seasons. So what Andre was asking about the transition between one season and another is not affecting that much, neither in the residuals nor in the time series. Maybe a bit more in here, because we see these drops from this drop it should be here, but because the change of season is from March to April. But yes, there are some differences between the seasonal profiles, and the rolling adapts more softly. But there's not that much change as would be expected.
Anyway, Maricruz speaking. Here, because of the y-axis that you used, it looks like it's really different, but the difference is quite small. Or do you think it's significant?
No, I don't think it is for
most
of the cases. 0.54 of the less oxidized.
Oh yeah, that is true. Yeah, I was looking at the COA or HOA.
Yeah, I mean, the main difference will be this LOA.
But maybe also if you do total OA, maybe it doesn't matter so much.
Okay, I will.
So the total OA, you should weight it by mass concentration.
Yeah, sure.
You cannot just average two factors together. You should weight it by the mass concentration.
Okay.
Yeah, I mean, like.
Well, here you could just add. You can just add the mass.
Yeah.
And then do the correlation. It's not mass weighted, it's just total mass.
Mm-hmm.
Yeah, but like I think for the comparison between the factor profiles.
Yeah, there you have to do it. Yes.
I mean, even though sometimes it's R-square looks very good, but some key variables are not really agree with each other. Then
this is the This is the R squared of the profiles.
Yes.
I see. That's not of the concentration.
No.
Okay, got it wrong. Okay, then you're right. Sorry.
Yeah, so any suggestions for this? Any more suggestions?
I don't know if we want to choose or discuss, or the only or major difference I saw was with the BBOA. So it was more similar in Magadino, because I guess one of the reasons might be that the contribution of BBOA is much higher, so it's better identified by ACSM, and also from the BC good burning, I think it was also a better correlation. I don't remember exactly. So that would be one of the not so much different. But like checking this would be the objective also of the of this kind of analysis, as we discussed in the last meeting. So based on the results of other stations, then we could maybe select which data sets are worth to be treated in this way. So because maybe it's not, as Andre was asking, if it's going to be done with all data sets. Maybe it doesn't need to be done with all, but just select 5 or something like that.
Yeah, I mean, it depends on how deep you want to go, you know, like if you want to compare, like, let's say 20 data sets, then you need to find a way to visualize, you know, some of the, I mean, for example, let's say the advantage of rolling, then one thing you can visualize it is how basically to visualize the 44-43 plot, how the PMF, the LO and the MO movements can adapt with the clouds of the 44-43 points. Then that's one way you should think about how to visualize it. But if you only do it for few sites, then you can just do a case study, then that's it. So, but I mean, I think most of people already have seasonal solutions and a well have rolling, then it doesn't need much effort, in my opinion, as long as we can find a way to visualize what I have mentioned, then that's it. But yeah, certainly we need to think harder about what's the better way to visualize those advantages of rolling PMF. But maybe in the end, it's not a it could be not an advantage, but I think it's still worth to show.
Okay. So we would end up, for instance, with a plot with I don't know which parameter, seeing the difference in the residuals, for instance, for BBOA between seasonal and rolling versus BBOA contribution or fractional contribution for the different sites. And then we would see if there is a significant improvement or not with the rolling versus seasonal as a function of the BBOA presence or contribution, something like this. That for doing these kind of plots, that's a lot. Or well, yeah, I don't know, but it looks like a lot of work than to have one data point for the for that final plot. If it's meaningful, it's worth, but
yeah.
You don't know. You don't try.
Yeah, I mean, this paper will be very technical, but it's okay. We should learn from it.
You just have to look first, like you did now, for a few more, and then you have to get away.
We don't hear you well,
more
Andre.
condensed way. So. And then maybe you can add others. But if you cannot show it in a condensed way, I mean, it's a lot. Yeah. Okay, you could also you can always show examples in the main text and add 100 pages of supplementary. I'm not sure. Yeah, it might be good to think, yeah, after having had a look at some sites in detail, and then see if one can condense it. So condense the information of the comparison.
Mm-hmm.
Maybe I can start with some more data sets, and we will see what outcomes we get. Can I make a call for people to send me some data sets and we see?
Yeah, I mean, you can you can try more data sets, but again, I think it depends which direction you want to go. So I think we can still look into more details about how to visualize this, but yeah, hopefully it will be easy, but I'm not sure.
Okay, send an email asking.
But at least from what we've seen and you guys have discussed, Ian, Francesco, and Marta, you keep thinking this is worth. Because the last meeting we said let's, since it's as you said, seasonal and rolling results done, maybe it's worth to analyze them. So we agreed that we'll have a look, and after having this look, we still agree that it's worth keeping with the work, or
Yeah,
I
agree. You just need more work. I mean,
and thinking about the other data sets, maybe there's I don't know, but Ian, you have looked at all of them. Maybe you have more clear in mind which difference in sources. If I don't know, taking another data set or two more now and plotting similar plots that we have now here will help you in identifying if you see another difference or so. Maybe that will help you in identifying a better way to for the QQX or coming up with a different solution. I'm just suggesting. I don't know. Maybe it doesn't help you.
Yeah, I don't know much. Like, at least from what I have seen, I mean, of course they didn't do same approach, same comparison, but they just do the simple comparison, like put the time series together, comparing the Oscar or whatever. They all look similar. So I think right now maybe still need to think more about how to visualize instead of ask more data, because I think if we know how to visualize it, then it should be
it will be easier.
It will be easier
to interpret. Okay.
Yeah, so we certainly need more play more on digging more, in my opinion. We just don't know how to show or quantify the advantage of rolling or do the fair comparison. So yeah, maybe, yeah, I don't know. I mean, we can also ask for help from some people who has data, from data scientists. Yeah, we can look at first. Just think more about it.
I would involve Kaspar maybe also, because I mean he has compared also different type of PMFs. I think during the time he was in Finland, so you might have some good ideas. I would involve him. This may be my suggestion.
Is not here now. Okay, and Francesco did not connect either, or Anna.
I don't think so. Francesco said he will join after lunch.
Okay.
Yeah. But I mean, if it's necessary, I will ask Kaspar. Well, maybe next time we can invite him to the meeting. Then let's just look for.
Show him the graphs that we have so far.
Yeah.
I mean, unless you don't want.
He was actually invited, but at least through eCost. I'm just checking now. Kaspar, I mean.
Yeah, he's probably busy. He's writing his ERC proposal.
What a small detail, Andre.
Huh?
No, I was kidding. What a small detail, I said.
Yeah, small details.
Yeah. Yeah, no, but it's, yeah, I agree. Sending a proper email is better than just receiving this invitation.
Okay. Then good. So maybe we can stop here and come back later. As scheduled, we will come back at 1:30. Then we can start to discuss about the outline of paper and the figures. Okay.
When was it? 1:30?
Yeah, 1:30.
Okay.
Yeah. Thank you, guys. See you later.
See you later.
See you.
See you.
Bye.
See you. Bon appétit.
See you later. Bye.
Il faut réfléchir à tous les cas d'optimisation possibles quand on bâtit le système. Et après, il peut y avoir plusieurs types de niveaux d'intervention. Tu peux proposer un produit marque blanche moins cher s'il est customisé en niveau 1. C'est ce que fait ServiceNow, par exemple. ServiceNow, c'est une techno, c'est un équivalent de Workplace qui fait la gestion de base de données RH. Beaucoup d'intelligence derrière. Et en fait, eux, ils proposent soit tu achètes la solution en belle direct, tu joues avec la bibliothèque de composants. Tu as même un éditeur en drag and drop, où tu mets tes composants, tu changes de texte, c'est comme une usine à site qui est gérée par l'IT ou des fois même par les RH. Et au final, tu peux ajouter des couches de front par-dessus. Sauf que ça coûte cher. Donc, généralement, il y a des éléments de démo. Voilà ce que vous pouvez avoir pour ce prix-là. Ça prend en compte, entre guillemets, tout le coût de l'IT. Voilà, connexion de tout ça et un peu d'organisation. Généralement, ils oublient de faire l'architecture d'info. Ils ont des contenus dégueulasses et tout le monde s'en fout parce que ça coûte pas cher. Ou alors, il y a une prestation où il y a un peu plus d'architecture d'info, il y a un peu plus d'UX, on va dire. Je n'aime pas ce mot, mais voilà. Ou alors, il y a le full custom où tu as un artiste designer qui arrive, qui choisit les couleurs, qui met en place des patterns incroyables, et au final, la connexion, en compte, tous les patterns fonctionnels sont masqués par le surcouche
Maybe we wait for a few minutes to allow more people to join. Hello, shall we start? Can you guys hear me?
Sure.
No?
Sure, Jan.
Okay.
We can hear you.
Yes.
Okay, good afternoon, everyone. Then let's start. So, as you can see right now, it's a new plot I made. So it included all the inorganics and the black carbon. So far we are still missing the Pudendome, London, Berkness, and maybe some of the data need to be updated, like Paris. But yeah, so it's almost done. And I added something. So like basically the green part will be the organic, and I just use another way to demonstrate the OA source apportionment in this bar plot. Hopefully you guys like it. And this map has basically classify the station to 4 types: remote, rural, urban background. Yeah. So it's color coded by these 4 colors, and hopefully you guys all agree with what I classified it. Hopefully I will find out more accurate after you submit the Google form. Yeah, so any other suggestions for this plot? I mean, actually, there's another idea. Actually, I can make, each data, basically each station, I can make it as a pie. pie chart, and the size of the pie chart could be indicate the total PM concentration. And then I don't need like 20 pie chart outside of this figure. Will be just within this map. That's another option. But I was trying to show it, but like because the timing is still I cannot get it done. But that could be an alternative. Yeah. So what do you think?
Aren't you afraid that it would overlap? I mean, there are some sites which are close to each other, like in Switzerland, and
yeah, I haven't tried that yet. But like when I look at the sample plot, it looks quite nice. I mean, from others, but yeah.
I agree with the comment that just came in.
Let me see.
Yeah, but I understood that was the suggestion from Ian.
Yeah.
Okay.
Okay.
And I guess you modify the legend on the type of station.
Yeah. Okay. So just add another information like the size of the dots will be the PM concentration. But we keep the pie charts and the bar plots all together. We still keep them.
It's good.
Okay. Let me just quickly make a note.
there is nothing for Copenhagen yet, maybe?
That's I think.
No, that's not Copenhagen. That's Sweden. No, that's.
That's not that's the one from Axel, from Lund. That's not Copenhagen.
Okay, but you will still need to make room for it. For the
I don't know. I mean, I feel I haven't been in contact with Axel for a while, so probably, yeah.
And the location for Athens. So I know there are two stations, but are they both same type of station?
One is urban, another is urban background.
Yeah.
If you change the dot size, it'll probably become clear since they have such different PM concentrations.
Yes.
And now I see you actually have two dots.
Yeah, they're
okay. I was only seeing the one color.
Yeah, if I make the size of the dots different, then it will be different.
Yeah, just make sure the right one is in front of the
yeah,
the one with the low concentration in front of the high concentration. Yeah. I mean, I doubt a little bit. I mean, some of the classification. Yeah, I mean, the remote in the Czech Republic, I probably wouldn't call remote. And in Romania, I also wouldn't call it remote.
No, for sure, Romania is not remote. Actually, I think Jan took this from the GAU. In the GAU, we are like regional because of the LiDAR data. They are considered regional, so the name of the station is defined as regional, but in Romania, it's very urban, actually.
Okay. Yeah, maybe please fill in the Google form, and then I can.
Sure. After the meeting, I will do it. Sure.
Yeah. Thanks.
Welcome.
And did you in the Google form, Ian?
Yeah.
You put these 4 categories?
Yes.
The ones you're using here.
Yes. Should I add another one
or let's agree what's the difference between urban and urban background? Because like Barcelona, we call it urban background because it's representative of the urban atmosphere, and Democritus is much more background, let's say. And I know there will not be equal stations and everything, but having urban and urban background, I would understand that urban is more similar to a hotspot, and for
is it more like urban background is equivalent to suburban?
Yeah, that's what I think. I don't know. What do you guys think? But for example, I don't think the rural background makes sense, or regional and the remote should be similar, right?
We usually make a difference between remote and regional. I personally prefer regional over rural, but
yeah, but like
what does regional? Okay.
Or maybe because for us, as we have these 3 stations, we call it urban, regional, and remote. But do we have any hotspot? No, North Kensington is not here, right? London is a London background, or
no? It's North Kensington.
Well, North Kensington is in London, but it's urban. So, but it's not a suburban. I mean, it depends how we characterize the urban background. So it's in the middle of the city, but in a residential area.
Yeah. So
I think that it will be similar to your site in Barcelona.
Yeah.
That is in the middle of the city, but not next to a big road or anything.
Yeah. So it's not Marylebone Road. Yeah.
No.
The Lille and Paris site, for instance, will be they're outside of the city.
I have a question. Do we really get much useful information actually out of? I mean, we would like to have the information, but we don't actually get the information by saying it's urban or urban background or remote or rural, right? It seems more a cause for debate, and then what becomes what is. I think that the main thing is to link really to the background levels somehow. I don't know how. I mean, I don't think you can classify the sites, is what I'm saying. I mean, really, I don't. Somehow one just has to know. I know it's like more complicated and more nuanced, but one has to know that even though you can call the Bucharest site a remote site, it's not. I mean, somehow you have to know. It's not so simple that you can just classify it. And for example, Birkenes, we don't. It's not really a remote site if you're. I mean, there is a city not too far away, and there's a settlement there. It's not remote compared to Jungfraujoch or Zeppelin, you know.
Mm-hmm.
I mean, you can keep, like, I mean, they are classified within actress or gore or whatever. By all means, keep it, but it shouldn't be. You know, I think if you just say this is the gore classification or this is the actress, and you give that information, then you don't. It's not really up for discussion anymore. That happens to be what it is, but you can more discuss them in the paper in terms of the background PM.
Yeah, I agree, but then we shouldn't do this differentiation between urban and urban background, because I think it's very specific and it can be misleading if there's not a clear criteria, as you said. And Elena had a suggestion in the chat, which could work also.
Yeah, but like, I just don't know how. Last time we agreed to be consistent with actress, but like I was trying to look into in a website. It doesn't seem to be anywhere.
No.
That's why I was asking around about the classification, but maybe
I would just call the legend actress classification. By all means, put it, but the main information can be this in the chat was this dot size in accordance with PM. I mean, I know this is not the dimension of of data, but yeah, because it's really difficult. Yeah, and again, Bucharest peri-urban versus urban, and I don't know, maybe some of the other sites would fit into this peri-urban description, and again, it becomes more complicated. The best classification for picking on Bucharest again is Bucharest, or what's actually the station called? It's like,
the station, it's called Măgurele Inoe, something like this.
Yeah, it's not in Bucharest even, is it? It's like a
yeah, it's 6 kilometers
it's like this
away
suburb
from Bucharest.
outside of Bucharest somehow.
Yeah, a little bit outside of Bucharest, yes.
Yeah, so also
this is why I said that it's very urban, actually, not urban like the definition.
So the name of the sites, should I just name it by city, or I think it maybe made more sense to name it by city instead of.
You have also to give the actress name for sure.
Okay.
Yeah, but that can be in a table in the supplementary.
Yeah, I think so. Yeah, and the name of the actress name should be in the SI, but maybe in this plus for to be easier to read, then maybe should be the city.
Yeah, I kind of agree.
Yeah, me too. For us will be Măgurele, and it's quite unknown even for Romanian people, otherwise for European or outside Europe. So yeah, I agree with Bucharest, and maybe put it in the description that the name in actress it's Măgurele Inoe, something like this.
Yeah. Okay. So, but other than that, looks good.
So what was now the conclusion?
Yeah, to be honest, I just made this plot a few days ago.
Yeah, but I mean, on the classification, oh
yeah,
the more simple classification would be just urban and non-urban.
Yeah.
Also between remote and rural, it's also not clear. I mean, Line also said Utila is not remote, but rural, but is then Birkenes remote if Utila is not? I mean, I don't know. I mean,
yeah, Birkenes is not remote.
Okay, but then nothing is remote actually.
No, not. I don't think you can have anything remote on the European mainland like this. You know, you have to go to North Scandinavia or somewhere in Russia, but it's difficult to get remote, right?
So basically, we have just urban, non-urban.
Okay.
Yeah, that's.
I mean, and then we can still in the supplementary add the actress description or whatever, detailing the.
Yeah. Okay. Yeah, I think I forgot to include the link, the description of your sites should be also provided. Okay. Oh, by the way, we should. So we'll probably make the data available as well. So how should we like include the Doyle in the SI as well, or just leave it so far? Because maybe I can imagine most of people still want to publish their own. So what's the solution for this?
And don't you kind of have to make the data open now, right? Or it's strongly encouraged at the very least, in some sense.
I mean, I would be quite pro that. I mean that we would put it in the EBAS database.
Yeah, indeed, and we can still have we have the Colossal. I can't remember the various options now, but you can password protect it as well.
Yeah, but we could also think about removing that. I mean,
it's an option.
Said,
you can have it without password, or you mean have it as its own kind of label framework, as they call it in EBAS. Now there are various options. You can also just make a DOI and put it on this so-called landing page, or you can have it as a date. You can have it. I mean, I would suggest to just put it in the Colossal framework. I mean, it's all, and then it can be password protected, but it doesn't have to be.
I mean, we want modelers to use the data, right?
A lot of it will be should be in Actress anyway, because it's not the
PMF result. The PMF result is not anything published yet, but in theory, we kind of said as soon as we have published the results, I mean, then we should also make them publicly available. But I don't know. Who feels like we shouldn't make it available? Maybe you send a mail in to everyone, see if somebody disagrees. Otherwise, maybe we can talk to the EBAS people to how we can also implement. I mean, how we can report the source portion results as well there, and then we can mention that in the papers.
Yeah,
this is available there.
I would try. I mean, I think we could do both. We could. This is a good reason to encourage the people to upload the data in EBAS, and then if we could just take the time series, the data sets, and assign them a DOI that is linked to the paper, I would do this.
Yeah, we can do both. Yeah.
But
I mean,
should each data set, each station has one DOI, or should be like altogether just one?
I would do it all together.
Yeah, it should be just one.
Okay.
And I don't know if there are directions for that or restrictions, but I guess the format is free, so it's maybe easier. I'm not saying data shouldn't be in EBAS, to the contrary, I think they should be, but maybe also for modelers and so it's easier if they just want the time series. Then again, they will be missing information, as we always say, but we should encourage that they also contact some of us also for extra explanation.
Yeah, I mean, we should. I mean, I don't know if now Olivier or somebody else there, if there's a new program now that has been written to facilitate it more easily to upload stuff in EBAS, but I think it's worthwhile to see with Olivier one more time.
I did last time. I think it was Evelyn mostly taking care of that, but I didn't see any major.
Yeah, Olivier or Evelyn or whatever. Yeah. I mean, in theory, it's their, within Actress at least, it's their job somehow to do that, or to provide. So I guess, yeah, Ian, why don't you contact Evelyn and Olivier to see how, if they have instructions, how we can do it in the easiest way now, or soon. As soon as it's published.
Yeah. Sure. Okay.
Congrats, Line.
I see. ETA. That's to eBus, right? I remember that software. Okay, thanks. All right.
Ian, I
Yes.
have a comment on the graph still,
Yes.
and I understand how challenging it is to incorporate so many colors, but it still seems difficult to read. And for non-experts, for example, which one is the composition and which one is the PMF legend is not very clear. And coffee and black carbon is black to me, or at least on my screen. And yeah, and nitrate and sulfate are not exactly the standard MS colors. I know how challenging it is, but it's just now blues are too close and like olive colors are too similar in order to see really on the graph.
Okay, yeah.
Oh, and I just realized in the upper legend we would be missing the OA, the general green OA.
Yes.
Yep. But then the green would be exactly the same as LOOA. So at least they are now. So
they're not.
Not completely, but
yeah, so I guess it depends on the screen. On my screen, they are very, very similar.
Let's optimize the colors.
Yeah.
But use for the first pie chart, as Jurgita said, the conventions of the AMS.
Mm-hmm.
I mean then I think for the PMF results, I mean there are some obviously factors that don't have there's no convention for coffee OA or whatever. So you have to just optimize to find some.
Yeah, sure. Yeah, but like also, do you agree? For example, should I sum up all other OA or like whatever is not like commonly seen OA? Let's say other OA, or should I leave it like this?
Why not leave it if
Yeah.
it's feasible? I don't know. My screen here is a bit small to judge. I mean, obviously, if you have just a laptop screen, you will not be able to read any number. You also have, if it's printed on A4, also, I mean, you need to check if it's readable.
I mean, if you zoom in a bit, it's still readable. I will say.
Yeah, well,
because
yeah, sure, but if it's printed, it should also be readable.
Yeah.
Yeah. Sorry, I missed the question. Are you referring to the numbers besides the bars?
No. I mean.
Yeah, sure, but Ian was also asking. I mean, I think in the overview of Jose, as I remember, there, I mean, everything was put together as other OA. I mean, kind of, that was.
I am.
Just I think it was just the HOA and then maybe the OAs and then other OA. I think the BBOA was even part of the other OA. So it was much less classes, but I don't know. I mean, my opinion, we could still try to leave it, but we have to see. I mean, everything needs to be readable, in my opinion, when you print it on and you want to print the PDF, you should be able to read it. You cannot zoom when you print.
Yeah. Kristen, what do you mean about patents?
I just mean like for, I know it's traditional, ammonium nitrate, sulfate chloride, organic aerosol, that is all, you know, we're so used to seeing it as colors, but you could just try to do a texture rather than a color. That would free up other colors to use for the, you know, PMF. And then everybody could see it. You wouldn't have to worry about color blindness or other issues for readers. Just a suggestion, if you can try it, you might see. But yeah, just a suggestion. I mean, you'll have to figure it out, I suppose.
Yeah, I think for the pie chart, I can at least maybe make the OA special texture or something. I mean, despite also including the colors, maybe. I don't know. Well, I will try. Thanks. Okay, so I guess.
Sorry.
Yeah. Go ahead.
In Jimenez 2009, there was actually HOA, SV, LV OA, or total OA, and other OA. That was all.
Exactly. Yeah, but especially BBA, we want to leave for sure.
Yeah. I'm not suggesting this. Just that we discussed that we did not remember. So in the meantime, I checked.
Yeah.
Also, what interesting is charcoal has the concentration is so high.
Again?
The concentration in charcoal is really, it's like in another magnitude.
It's going to be a big circle.
Yeah, I noticed that before. I thought I had same thought.
Yeah.
Oh, that cannot be true.
But it's over which period?
But that's not true, Ian. It cannot be.
Maybe it's wrong.
That's wrong.
Maybe
No.
It should be 12.
Yeah, that's not possible.
Yeah.
No.
Somehow I made a mistake.
I mean, in winter it's quite high, but even in winter it's not 120. No.
Okay. Yeah, that's wrong then. Thank you.
Yeah, I mean.
Yeah, good.
You might also put the numbers in a table in the supplementary. Then it's easier for somebody. Also for colorblind people can check there if it's difficult. See it.
Yeah. Okay, so maybe I think the outline should be what we have discussed last time. About this should be rather clear. I mean, this plot I will update. The messages. So the protocol will be in the main text. And this is basically the first figure. As I said, as you suggested, but I haven't done yet. So just include whatever data is analyzed for this project, but this figure will live in our website, I guess. Then everyone can check the availability of the data.
So we will show only the data that is used. Is that right?
Yeah. Yes.
Yeah, that's good. Because now also, I mean, it's bad that there's no data after 2019, which I believe it's not true.
No. Yeah. Okay. And this one will be the figure 2. Will be basically the steps of the protocol. And I mean, this could be part of, like, because we will include the protocol in the main text, and this can be a nice figure to explain. And this one we have just discussed. And this one, I mean, this figure I just made yesterday, I mean, the distance between each other, and I still need to figure out how to do it. But this is the concentration stacked for each OA factors. So
well, now you have 5 times the same graph, right?
Sorry?
Now you have 5 times the same graph.
Oh, yeah. Okay.
It's,
I didn't realize.
Right.
Somehow,
they look awfully similar.
Yes. Okay. Yeah, it's the same.
Yeah.
What happened? This one should be also the same, no? Yeah, it's also the same. Yeah, I made a mistake. Yeah, but anyway, I will update this. I think these 2 graphs, we need to choose one of them. The one is based on the absolute value. The other is fraction. Yeah. Yeah. What do you think?
I'd like fraction with the number above, but yeah, because in this absolute, you cannot see the lower concentrations at all.
Yeah.
The fact that Krakow is an order of magnitude higher than the others doesn't help, and I agree that the best would be to have the fractional and the number on the top.
Yeah.
The question is how we should order the stations.
Sorry?
Now it's alphabetical order.
Okay. Yeah, now it's alphabetic, but I don't think alphabetic. Yeah. I mean, we could do it per either concentration, latitude, or I don't know what.
I think it will depend on the discussion on the paper. If we want to focus on the latitude distribution, or if you want to group in the rural versus urban or something like that, then we have to plot accordingly to this discussion.
Yeah.
I think they should be grouped according to the previous figure. So if we decide urban, not urban, and then inside the urban, not urban, you can make it somehow alphabetical.
You can make it, what did you say?
Group it according to the previous figure, so it's concise, and then inside this group can be alphabetical, or whatever sorting
or per concentration.
Or per concentration, yes.
Yeah, I think the per concentration I'll do for another figure.
That's true. We have that differently.
Yeah, I haven't made this. I will just use as an example, but I still need to work on this. So for this figure, I think so far I already start to process the data, but my code has a lot of bugs. But I can make it 8 groups, 5 microgram per group, and until 35 microgram. So in total 8 groups, but I'm not sure how many figures we want to show. Like here it's showing every season, but should we show also like basically show every station? And also here, I think we should do more classification based on latitude, for example, or whatever, or temperature, average temperature, or yeah.
Here are all the cities, the data sets, or just some of them?
Sorry, say it again.
Here are all the data sets, or?
Again, I mean, like, I think the brown color and the yellow color are cities.
Okay.
And the green or blue should be rather, or whatever, non-urban.
Yeah, but for the figure, you mix all the stations.
Yeah, and I think maybe it's better to put it like one plot for urban and one for the other, I don't know, background or remote.
Non-urban, urban. So
yes, it depends on how many kinds we stick with at the end.
Here in figure 6, you've taken all the data from all the stations together? Or is it just one example for one site?
This is just one example for one site. So I think what we should do is, I mean, like, should it be at least, yeah, I don't know. I mean, this is, so one simple way to do is maybe each graph will be one side, and each side will have 8 bars, and we make a left will be the urban, right will be non-urbans. Well, in total will be so in the left, well, here it now has 4, but we may have 10, 12 for each. For example, urban, well, we have 10, non-urban have 10, another 10. So maybe we'll be quite crowded, but yeah.
Can I suggest first to make those graphs for every station and then see if they classify easily? For example, if you can see that all urban shows the same pattern, then yes, you can classify them. But if they show different patterns, then I would not suggest combining them. So maybe just doing first for every station and see if there are patterns emerging. It's a lot of work again.
I mean, but it's worthwhile to do it per station anyway. I mean, then these plots could be put into the supplementary in any case, and then, but it will maybe help the discussion. Then one could check a little bit if the tendencies are the same. That, I mean, for example, I mean, maybe, I don't know, I say something, maybe in urban areas, always the BBOA is higher at higher concentrations, or I don't know, I mean, then you can check in the supplementary and show just an average of the urban stations, maybe in the text, but I don't know. I mean,
yeah, I think we expect to have different primaries in the urban than in remote or rural, at least, and also the fractions.
But if you merge, it may be difficult to take into account specific sites which have, like, specific PMF factors.
No,
like
I don't think
OA or wildfire OA. How do you account for that?
I don't think we should merge them into one bin or something.
Mm-hmm.
Doesn't make sense to me. I mean, each station should have its own bin, but if you classify it as a similar, whatever it is, latitude or urban, non-urban, maybe one could done is maybe just put the bin side by side were, I don't know, or like this, maybe 10 bins for one group.
Which site is this actually?
This is from Yunjian's paper in Paris.
Okay. Yeah, I mean, here you could also show it differently. I mean, you could show you could make a line. For example, that you could say the BBOA fraction, and then you plot it as a function of concentration. For each site, you have a separate line. Then you just put the BBOA fraction or the OOA fraction as a function of concentration. Now for each station a line. And you see if the tendency is always similar. I mean, does it increase the fraction with high concentration, or you see a little bit, also the absolute difference of the relative fraction. But I mean, this way you could maybe put more information in one graph. See what I mean?
So
I'm not sure.
I think that would make the comparison between stations easier for the eye, but then the comparison between seasons for the same station more difficult.
Yeah, that's true. But
seasonal... I'm not. Maybe we can try, and then, as Jurgita was saying, plot everything and see what is more worth to explain.
Yeah, that's true. I mean, that's the question if one actually needs or wants to do this per season, different per season. Yeah, then there's many options.
Yeah.
I mean, partially the season we have here, right? I mean,
yeah.
But that's just not as a function of concentration, but just to give a general. But yeah. Yeah, I mean, you need to get some more final data, and then you need to start making some examples, graphs.
Yes, because at least for the example, Ian, can you go to the next figure? At least for here, if you take the average of the whole year, I don't know, you would miss a lot of information, because from the third season to the from summer to autumn, you have the low oxidized. In the summer it's increasing, in the autumn it's decreasing, and then maybe if you do the average, then you don't see. At least for this side.
Yeah, sure. But I mean, you don't see it so well, but I mean, this is the frequency that the dots is on a logarithmic scale. So obviously, I mean, the high concentrations are probably anyway only found in winter, basically, and surely the high concentrations will be dominated by winter. But yeah, I mean, one should, for example, in summer, you should not over-interpret anyway the two highest bins, because that's basically no data. I mean, it's also sometimes a bit misleading, yeah, because it's so few points. I mean, this is less than 1,000th of the data, and that is making those two bins in June, July, August in this graph.
And now you made me think about the bins. Do we want to have them as same concentration, so in absolute concentrations for all the stations, or in percentiles for each station? Because for some of the stations, maybe there's zero data for the last bin.
Yeah.
Which would not be a problem, but as we also need to decide.
Yeah, if you want to compare stations, it's interesting to have the same scale, but yeah, but I don't know. Yeah, it's always a question, what do you want to compare exactly? you want to compare with the inner station, the seasons, or among the stations, or give a general overview over Europe, or a general overview over the urban sites, or a general overview of urban sites per season. I mean, it's many options. But I think Ian, I think you have to make some more real examples, just to see how it looks like before one can judge. I mean, as Jurgita said a little bit, I mean, one needs to get a little bit a better feeling of how things classify, or I mean, what are the tendencies that are interesting to be pointed out, and maybe one can be led by this. I mean, if for example, as I said, I mean, if the biomass burning fraction always goes up, higher concentrations, that's something then to think about how one shows this in a good way. Or I don't know what the tendencies will be exactly.
Yeah,
it will depend on what the conclusions are, and then maybe we choose the figures according to what we want to say about.
Yeah, I think now, I just simply don't have enough time to do so. But
no.
But I'm working on it. I think maybe, I guess I can send you guys the figures once I finish them, or what do you think?
I mean, is there in Sophie something like this that you could make this graph?
No, I have to code by myself. So, for example, those plots are really time consuming. Yeah. And this one I was coding yesterday and not successful, but I have all the data now.
I mean, this would be a nice graph for Sophie.
Yeah, I think so.
I mean, this for individual sites at least. I mean, this will also be good. Then you can still.
And now it's mainly grouped by the monthly, weekly, or whatever. It's not done by this way yet.
Oh, but you could group by months, no?
Yes.
Only by 12 months, not by group of months.
No.
I see. Then you need to give it a new name, whatever. Yeah. Okay.
Yeah. So, yeah, but like I think. Yeah. Okay. I will work on this plots. And yeah, I didn't realize those figures were wrong. Yeah, that's a pity. But, okay.
Yeah, don't worry now.
So, and this one, I think it's real, but it's not the update yet. I think last time we mentioned we need to put this in a supplementary. I guess. Or any other suggestions? Yeah, so I mean, for this paper, we should focus more on the temporal variation and the spatial variabilities. But like above, all those figures should be already quite informative, in my opinion. Yeah, this one will be just daily average. like also for the profiles and diagonals, those things could be also, yeah, it should be in the main text, I guess.
Yeah, this one should be supplementary. Yeah.
Okay, yeah. Yeah, Lina,
Are those data from rolling analysis, or?
Yes, those are all rolling. I think Hutiala is just from 17 to 18. This part. It's not this much. Yeah, I mean, this plot will be anyway difficult to show because the Magdino is quite old and the others are rather new, so but I think the whole point of this plot is like you can see the overlap period, how this fraction changed. Okay, so yeah, I don't know what else we should discuss.
There are more figures now.
I think other figures are just old. So those figures will be also, of course, included. And this one will be just, I think for maybe Calico, or not Calico, but using the size or whatever to indicate the latitude, I guess, the temperature. So yeah, I think I just, yeah, you know, not have enough time to make those plots, to update those plots. Yeah, I think that's all. Any other ideas of the figures?
I mean, after now this F44, F43 is changed.
Yes, but that's but the plot of the location of the factor profile is not changed. It's just the model, the measure points are changed.
Mm-hmm. Yeah, I don't know, but it might be worth to have a look at this again after it's corrected. If one, I don't know, if one somehow wants to make use of it. So, so you're saying the graphs are, that's corrected. That was always correct, you say.
Yes. So yeah. These plots will be always correct. I mean,
these are correct.
These are just the factor profiles for each data set. So, I mean, so it will be always like that, unless your PMF change quite a bit.
Here it's again the same plot 5 times.
Yeah. I haven't. I just make an example. I mean, it's not updated.
Yeah, maybe include the total OA as well.
The total OA, you mean? Just
I mean, weighted OA.
Okay.
I mean, it's just I'm still wondering if on average one can see a movement that is similar for all sites. I mean, if one would, I mean, in theory, one could also make the plot different. One could say, one could make a, you know, one plot per site. I mean, one line per site, putting the position for the different season, and see how it moves. And the question is, does it always move the same way? I mean, that's still my question. I mean, do we see? I mean, if the hypothesis is like in the paper from Francesco that it's more biogenic in summer, then you're more to the right, and then we have more biomass burning SOA in winter, and it's more to the left. Just a question how consistent this is for all the sites. So I mean, eventually one sees it when you do it the right plot, but one can also eventually one can also plot it differently. But I'm still curious to see this somehow. If this is really if there's a consistent change.
Okay.
I think that will still be interesting. I mean, in the also describing the text, or I mean, it's a question what we learn from it. But I guess the main question is there a consistent change, or I mean, or some sites maybe don't have that, and one can think about why. I mean, then maybe they have different characteristics of sources, or something, or different characteristics of aging, much more aging than the other sites, or much less, or whatever, depending on maybe latitude or season or something.
So when you say the total how can you basically just make it like for different season and see how it changed? That's it?
No, I mean, on these plots, in theory, you could just add a third dot just for the total of it.
Okay.
But then we should have a look. I'm just thinking one could then, if you want to look at the movement, I mean, you can stare at these figures, but you could also just, you know, for example, take the dot. Maybe for the total OA, it's easier. I mean, then you take, for example, the September, October, November, then the December, January, February dot, then the March, April, May dot, and the June, July, August dot. Then you put that per site on a kind of like as a circle or something. See if the movement is the same.
Okay, I
don't
see.
know. I mean, I'm not sure if that helps. But I mean, you need to see if one sees some systematic differences between sites and or also the movement between seasons. So I'm not sure if it needs an additional plot or not, but I mean, at least you need to look at it and then make a proper discussion in any case.
Yeah, I see.
Yeah, I think things will come up when we have more final versions of plots. Then maybe you have to face the fact that maybe there are more ideas for plots when one sees the actual plots.
Yeah,
because they will open up questions, but I mean that is necessary because you need to also to describe or also interpret the stuff. So you will need to do additional things. I mean, as soon as but it's really, yeah. I mean, you don't want to do that 100 times. Yeah, that's why we haven't done it so far. But now we're nearly close to have it finalized. I mean, all the stations. Then it's worthwhile to do it.
Yeah.
So I think this step needs to be done. Yeah, it's somehow to really peel or I mean to get out what is really interesting now in this comparison.
Yeah. Maybe. Yeah, Francesco, are you here?
Yeah, I'm here.
Yeah. So could you possibly implement this
Yeah, I can think about this, sure.
Yeah, because it could make my life easier.
Okay. I'll do so. It's good.
Yeah.
So it's basically in what is this?
A group by the concentration of OA.
Mass fraction group by concentration, and then with the frequency on the axis. Okay.
Yeah, exactly.
Okay.
I was trying to. I wrote some codes already yesterday, but so far it's not still debugging. So.
Okay. I'd rather know, but it's good.
Yeah.
I think it's a nice graph to be able to look at.
Are those the graphs that we also had in Monica Kripa's paper in the European overview from, what was it, 2013, 14?
Could be, yeah.
Okay.
I don't think so.
I think we just had much more bins.
Yeah.
I think it's like something like this.
No, but we also had, I think, something according to the concentration. I think we made much more bins.
Yeah.
Okay.
I mean, that's the question, how flexible you want to make it. I mean, if you want to let the user define the bins and whatever, because that obviously the concentration range will be quite different for different sites. So maybe you just adjust it, and then you can maybe choose the number of bins.
Sure, yeah.
Something. But yeah, it's a nice, useful graph. I think you often want to see, because you want to know what is driving the haze at high concentration. That's something you want to kind of communicate, so that you can check, I mean, what is the relative contribution at high concentrations versus at average or low concentration.
Yeah. Okay, well, that is so that's good. Yeah, no problem.
Okay, so
yeah, maybe Ian, I mean, maybe you could, I mean, when do we have the next meeting?
I think the next will be the end of March.
Okay. I think it would be good to see updated figures. I mean, that if you can send them around way before the meeting, so that one can maybe look at it and make suggestions, so that otherwise it's inefficient. I mean, to look at the next meeting just the new figures, but not having time to have a look at them, I mean, oneself. So I have a feeling, I mean, you should first make new graphs, then give the people time, at least 2 weeks, and then have the next meeting. So it depends how fast you can do those.
Yeah.
I think it doesn't make sense to. I think it needs time into thinking, and maybe one needs to tell you, well, why don't you try to look at this figure as well? Try to make those. Then, because for the interpretation, it's good to spend some time.
Oh, okay. Next meeting is overlapped. Or should we? I will send out another email. Maybe possibly postpone it. Then.
Yeah.
Or should I? I think I can do the poll right now, but like I'm not sure. Or should I send out a doodle again?
I don't know. Did we fill in a doodle for this
yes.
March meeting?
Yes.
So maybe you can use that one and see another day that works for most of us.
Yeah, I don't know.
So maybe we should do it a little bit later. To be sure.
Yeah. I don't remember till which date was the doodle in case it was.
Yeah.
You mean postpone it more than 1-2 weeks?
Yes, maybe.
Yeah, we maybe could make the meeting in mid-April. Still be good. I think
mid-April.
Well, or I don't know. I don't care. I mean, it depends a bit on you, Ian. I have how fast you can make. I mean, also the other. I mean, for those that haven't not yet, obviously it makes the life of Ian easier if really all the data is there, so one doesn't have to update these figures anymore at some point. So I don't know. What do you think, Ian? When will you receive all data?
Yeah, so far I haven't received from Abilene. I mean, also London, Berknes, Leslie data I haven't received, and some of the data still need to be updated. Yeah, so it might still take some time, I guess, at least 2 weeks, I think.
Yeah, I think I would only start then to do these figures. Actually, then it's more efficient. Then you really have the final figures, and then you make the figures, and then you send them around, get input for the figures, and then we have a final meet.
Quick question, Ian, is there a list or a link somewhere like what exact data you want? Like, is it just a time series, or you want 44-43 ratio, all this kind of stuff?
Yeah, so far I just asked you to send me the PXP. Yeah, maybe I guess I will try to maybe make a list or something in the future, because
I mean, I'm happy to send the PXP. That's of course easier, but then you.
I know.
I can already send you the summer and winter PXPs, for example.
Yeah, I will think about it more. How to be easier to make this, but I mean, the PXP should be contain everything already. Yeah.
Yeah, I think it's the most efficient if you actually, as I said before, wait for the data, then make the figures. I mean, eventually, if you want the individual persons to contribute to making the figures, you have to maybe get additional stuff, but you need to think about that, and then we do the final figures and then send them around. I think then ideas will still come up, and then it's also more clear which direction then some of the messages could go, or what we could still try to work out a little bit within the data sets. I mean, we want to show a bit more than just showing. We don't want to just show the data, also a little bit provide a little bit more insight.
Yeah, of course.
But I think it's easier if you really have the final stuff there. Otherwise, we keep going forth and back.
Yeah, and it's very difficult to decide on the figure. I mean, we reach a point where it's very difficult to decide on the figures without the final data, as you're saying.
Yeah, exactly. Let's rather wait a bit, because otherwise you also just do the work twice or 3 times. I mean, that doesn't make any sense anymore. It's now too close to finishing. So rather we're a bit later, but at least everything can be done at once, then in a good way.
But yeah. Well,
so we need a firm deadline now for the final date.
Yes, I was gonna say, because if we wait for the very last
exactly.
data set, then I mean, at least if we have 80%, we can start seeing and then just update it once, let's say.
Now we are at 80-90%, but I think we want to have all.
Okay, if we're already there, okay.
Yeah, I think so. But I mean, as I think it's mostly these 3 sites and maybe some small updates, but they're probably already, it's mostly done, right? But so Ian, yeah, you had, or what deadline is realistic from those people? Did you know? I mean, Birkenhead seems to be soon finished, right? London
as well.
London as well. Pudendom, do you
I
know?
don't know. I have no idea.
Okay,
Yeah.
so let's.
I asked Kathleen to present today actually, but I think she was busy. She's busy.
Yeah.
Yeah, Paris might take another at least a week or so. So I think that's, yeah, I don't know about.
Should we say a firm deadline 15th of March?
15th of March. Yeah, I think it should be visible. 3 weeks.
You only include stations where you have data.
Sorry?
You include only the stations where you have the data until March 15th.
Okay.
Is that okay with everyone? Or
sounds reasonable.
I mean, at some point we need to wrap up, otherwise we never wrap up. Okay. Oh, let's do it this way. So Ian, you contact Evelyn, or you want me to do that?
Yeah, I think I'm okay. At least she answered my emails.
Yeah.
And so if you, let's say, Ian, you have all the data by the 15th of March.
So I'm saying that you need 2 weeks to make the figures.
Yeah, and
then in 2 weeks after we have the meeting, so that gives around mid-April.
Yeah, that would be more the week of the 19th of April. The previous week is there's this SOFI users meeting, so we don't want to overlap.
Okay.
Or we could do it on the Monday 12th, but
or
to next week.
Okay, to do it together. I mean, anyway, yeah, I don't know. Have they many overlap?
Or we can do it on a morning, because the SOFI users is in the afternoon, if I didn't write it down wrong.
Yeah.
Maybe, I mean, if we have the figures in advance and we really take the commitment to look at them before the meeting, we can be quite efficient. Maybe with 3-4 hours, we should be able to solve.
Yeah, let's try to do it. Fix a morning there in the same week. Then everybody's anyway, or a lot of people will want to participate in. So make a doodle for those days where the workshop is anyway.
Yeah.
Cool.
Yeah.
Oh, this is great. We're kind of reaching the goal. Feels good. I guess for you, Ian, must feel good.
Yeah, it took me quite a good time to make this plot already.
Yeah, I imagine.
Yeah, but it's close. Yeah. I mean, at least this pie charts, you know, they're quite good already. I mean, not so many left. So I will send out a email about this workshop deadline and also about data submission, and then should be it. And also I will probably provide a list about you know, what I wanted to make, then maybe in addition to the PXP you send me, I will also ask some of the other data. Then we can all be more efficient.
Yeah, maybe you want to see also this updated F44, F43 plots.
Yeah, true.
For the site, so maybe you can ask that from the people, that if people can redo those plots. I think they will be good for interpretation in any case, and then you can still decide if some of those go into the supplementary or not. But I think it's good for the discussion interpretation.
Yeah. Yeah, Jenny, do you want to quickly show your updated 4443 plot? I think most of people have seen that before. Maybe it's good to see what's after the correction.
Yeah,
So,
I didn't had prepared nothing, but I can open the experiment actually. I think so. You wanted to show the last average with the last Sophie that you sent it and Francesco?
yeah, exactly.
I suppose, yeah.
Because I think Andre also looked at your 4443 plot before, so
okay.
It's good to show the difference.
Yeah, sorry, I have.
You sent me the new one. That's fine.
Yeah.
Yeah, sure. But maybe others can see it as well.
Sure, I will try it. Let's see if my experiment works. Yep.
Yeah, take your time.
Let's share my screen.
Well, it's a question, can you still show the old one and the new one? I mean, that would be the most intriguing.
Yeah, I think I can, yes. So now I think you can see my screen, yes?
Yeah.
Okay. I think I have all the graphs here, but yep. Okay. So these are the new ones, and let's try to find the others. Okay. So the issue were that we have for F44 up to 1, I think. So it should be around maximum around 0.4 something for F44, and for almost all the seasons except the summer one. When we extract only the secondary, we have really high values for this, and we tried a lot. We struggle with this issue, but and at the end, when we re-average with the last version of the Sophie, we get nicer plots. We still have some points that are a little bit above 0.4, but they are looking much more clean.
Yeah.
Can you show the summer?
I can find it, I suppose. Let's see. This is the summer.
Yeah. So I think the cloud of their data is rather always vertical.
Yeah, which is peculiar. I mean, as if also in summer it's more biomass burning related. But I mean, I would have expected also more terpene related SOA in summer in Romania.
Sorry?
I would expect more biogenic terpene related SOA in summer in Romania as well. Then it should follow a little, one would expect to follow it the right. I mean, a little bit, I mean, it's a question, you know, that's why I was asking Ian. I mean, if you average it, I mean, for example, the total OA or whatever, and look at the movement, still a question if it moved from the right to the left and so
on. I can try. I didn't have here the average in this experiment actually. Yep, I have only separate LOA and MOA.
Well, it's a question if one should always still remove the lowest 10% of the data of the concentration.
Yeah, actually this happened in our data when we have really low concentration. So for, I don't know, it was a spring value, something like this, with below 0.5 micrograms, and almost all the weird points were because that period.
Yeah, that's fine.
Yeah.
I mean, in theory, I think one could make these plots and then remove the lowest 10% of the data.
Actually, that weren't only 10%. I think I can open another experiment when we try to fix it. The things doing an artificial thing, let's say, and removing some points and still to look nice, but there are not only few points, are I don't know, around 50%, something like this. Oh, come on.
You have 50%.
Yeah, it was above 30%, if I remember correctly. Yeah. I think this is the experiment. I don't remember very well. It's something like this. So
what is this?
You remember that we define residual to mass for MZ44, and try to remove at the beginning those values that are somewhere weird. So this graph, which is look pretty similar with what we get it now from the new SOFI version. We did this manually, more or less.
Yeah.
And you see how many points we excluded that.
Yeah.
To have nice. Yeah. So
you're saying you have a lot of peaks?
Yeah, we have a lot of points that actually were excluded in this manner, like we did it manually.
Okay. Can you show the plot in the middle behind the one? No,
this one?
Yes.
This one with the time series?
Yes. So that's the.
What is this? Sorry.
That's the residual of of 44.
44.
Yes.
Divided by the mass concentration of 44.
Yes.
That's the relative or the absolute.
That's the ratio. It should be the absolute.
The absolute, if I remember correctly.
Okay. So is this unusual? I mean, I don't know. I mean, could it? So it means you have a lot of peaks or individual events where there's a lot of 44 in the residual. So that means there's maybe a source that is that has no only 44. I don't know. I'm just curious.
I mean, this could be, you know, this one sometimes could be dangerous also when the MZ44 is anyway very small, then this number get very big.
Okay, but so it's not absolute, you're saying? Oh, it's absolute.
It's the absolute residual, but we had it the ratio at the end.
Yeah. Then so the ratio of residual versus the total.
Yes, over the mass of MZ44.
Yeah, I mean,
because we look at the waves actually, and we saw that we have big residuals when we have small values of MZ44, or when we have a small concentration of organics on the total, and then we try to figure out how to deal with it. And this was what we came up at the beginning, but afterwards this is done in SOFI now. This is just to show you how many points we had to deal with, and there are some. Not only 2% or 3%, there are many more.
Yeah, I'm just thinking what the reason could be.
Actually, when we look at the data, we saw that when we have, let's say, more noisy data, so where the sensibility should be higher for the instruments, so when we had to deal with concentration less than 0.5 micrograms.
Yeah, I think Jenny, this you know, proportion could be much smaller if you do the same for the newest version of SOFI.
Yeah, for sure. Yeah. This is just to have the look on the points.
Yes.
Okay.
Yeah, I think this is
okay.
all I had.
Maybe I still don't 100% understand what is blocked. Okay.
Okay.
Fair enough. I just thought there's an indication of a source that maybe includes a lot of 44. Just curious if it's true.
No.
But that is different. Yeah. Okay.
Yeah. So I think Benjamin is here. Could I ask you a few questions, Benjamin? We talked about.
Hello.
Yeah. Hello. How are you?
Fine, and you?
Good. So we were talking about your data this morning about the P correction. So because none of our data has done the P correction except yours, could you? I mean, do you think it's easier for you to back calculate or to somehow to you know, to make your data like non-P corrected?
You mean if I can do that on my PMF solution, maybe I can do something, yeah. I mean, then actually at the beginning I did the P correction, but it was really, really low. It was like less than 0.5%, I guess. of the F44. So that's really nothing. I mean, for sure, I mean, the solution won't be different. I mean,
yeah,
I can try to do something on my data, but
I mean, we want to write in the paper that consistently there was no people correction.
Okay, so, yeah, and I understand the point.
You need to, I mean, either you need to run it again, but or you just make this. I mean, you back out the small correction. I mean, there's somehow.
Yeah. Okay. Yeah. No, I see. Yeah.
Or something. I think it's okay if the change is so small. From what we know, it will not influence the PMF solution much anyway. So it's just about the absolute.
Of course, yeah. Yeah. I guess I can just rerun everything, and of course, I mean the solution won't be any different, but still I can do that. Yeah.
Yeah. Thank you. Okay.
Before the 15th.
Yeah, before
the 15th.
That's now the strict deadline for all data sets to be final.
Ah, yeah. Okay. Okay. Easy.
Good to hear you, Benjamin.
Yeah, you too.
Okay, so yeah, I don't remember who had some questions for Francesco this morning. Is that from Anna or Hasna? I don't remember. If you guys can remind me, then you can take this opportunity to ask me directly.
I had something particular.
Yeah. Could you?
Not here.
No, I say that I don't have anything particular.
Oh, okay.
Sorry.
I'm here anyway. Never mind.
Yeah.
We mentioned Francesco when Marta was showing with the QQX, but I don't know if you mean this moment or another.
Yeah. I'm not sure yet. That one.
What's the question exactly?
Yeah, maybe you can show the graph one more time, Marta. Why not? This last graph from your presentation. Then good to hear Francesco's opinion on that. What?
Can you see? No, you can.
Yes.
Yeah.
Ah, you do? Okay.
We do. Yeah. We don't see the last slide yet.
Yeah. Here it is.
Yeah, we were wondering what you can really learn from this.
I mean, the distribution, yeah.
Okay, so those are now the Q distributions. Give me a second.
I mean, so I understood from Ian that the total Q is then the sum of all these somehow. And in theory, the sum is obviously then proportional to the area below these curves. But I don't know what you learn from the shape or whatever from the curves.
No, I think from the shape of the Q distribution, I think we don't really learn anything. I think if one wants to plot histograms, I think I would rather do the scale residual distributions. For Q, I will just take the QQX value, just the sum, and then normalize by QX.
Okay.
Just compare the two values, QQX from rolling versus QQX from the seasonal.
Okay.
Yeah.
So one could, yeah.
Okay, I'll do.
So yeah, you could still do that for different seasons or whatever as a function of time, right? I mean, the Q over Q expect.
Yeah.
I mean, you could sum it up, but then we still show it as a function of time, right? Or not?
I mean, the rolling, you could, for example, do this also for the seasonal. You could do this also as a function of time. but then you have to change the QX because the QX that we have now is basically considering the entire thing. So it's basically, considering also the rolling mechanism, the number of rolling windows, and also all the seasons for the seasonal QX.
And how would you modify this?
I think if you just do this per rolling window, then it's just the regular expression. You don't have to. So the 14 falls away, and then.
It's true. Maybe you could actually show the Q over Q expected for the seasonal would be then one line per season, and then you could show the variability of the Q over Q expected by the rolling. Then you can see there may be periods where you explain it better, and maybe some periods where it's the same, or I don't know exactly.
I could imagine, by the way, it just occurred to me one small problem with the comparison, because the down weighting, at least as I was told to do it, was based on the average signal to noise of a variable. And down weighting will affect the Q if there is any level of down weighting. So for example, for Birkenes, there is quite a lot of down weighting, right? So if I take the average Q over a window, I mean, is it maintaining the, I don't know, I would have to think about it, but
yeah, but that's true, the down weight is different, yeah.
Didn't you write a code once, Francesco, where you kind of corrected for that again?
Yeah, you can basically present the results with and without the downweight values. This is possible.
Yeah. But which one should one compare?
Yeah, that's the question.
I mean, which one is the actual? But I thought it would. Yeah, the Q expect is different, no? I mean, when you downweight. Then the past
Q
we didn't take that
is
into
only the
account.
degrees of freedom, the number of points, right? It's just normalize the Q. But then the way the weighting works is to increase the errors, right, on the downweighted.
Yeah.
So you will have a different scaled, like the residuals, different scaled, and then I'm not sure.
Yeah. I mean, I guess if you have different downweights, between rolling and seasonal, for example, then I would rather compare maybe just QQX without the downweight. No?
It's still not independent. I mean, it's still not because it's a global fit, basically. So you will get the individual Qs, right? The individual scaled residuals for each point in time, but the global minimization has still taken into account the downweighted values. So it's going to be similar, but it's still not going to be exact. You know what I mean?
Did we have a similar discussion before? That's why you put those options, but I don't remember what was the conclusion.
Yeah, me neither. We had a discussion a couple of years ago, and that's why I implemented both features, both possibilities. But I don't know. I don't remember now why. I also implemented the option to remove the robust mode to calculate the QQX. But yeah.
Okay, maybe we cannot solve it right now, but this is yeah. So you need to think about it and discuss it one more time, and then maybe give Marta a clue. I mean, it could be interesting because that's, as Ian said, I mean, just look at the residuals themselves. They're logically, I mean, the residuals will be worse for the seasonal, that's clear, because you just, yeah, the way you do the rolling, it's logic that it will fit the data at the end better.
Exactly, because you have more degrees of freedom. But that's why I
But
suggest
the question if there's a difference in the queue, but although I guess there will, I mean, that one shouldn't expect the difference. So I'm not sure. Or would one?
I mean, one expects Q to be also smaller because Q scales with the scale residuals. If the scale residuals are smaller, also Q will turn smaller. But that's why we were doing this, you know, I think a weekly resolution, or either weekly or Martha, this is weekly, right? These are weekly resolution plots.
Yes.
Yeah. Because then if you still have some structure here, then this is real structure that, for example, the seasonal is not able to model.
Well, no, but I'm not sure here. Well, it's just variability in the Q over Q expected. But does that matter? I mean, if the total sum is the same. Yeah, I don't know. This needs more thought.
And Martin, do you also have the scale residual histograms we were looking at last week?
Yeah, this.
Because I think those are more relevant.
Yeah, those are clear, more clear.
Yeah, I think those are more important. The Q.
But the point was, I think, from Ian that this is okay, but on the other hand, it's kind of clear that the rolling would always do better.
True.
You would have less because you. Yeah, I don't know. It's still a question if, I mean, how one needs to argue. If this is still just, if one stops here, it's okay. I'm not sure. I have to think about it. I think we had this discussion once with Caspar and Jane.
Yeah.
We should repeat that discussion. Why I was suggesting also to involve maybe Caspar to think about this, how we compare. Because I mean, he has also done new work on different schemes, and then it's a question how you compare things in an objective way. I don't know. I'm probably also not the best person to be able to say it right away.
Yeah, so
does the scale of the frequency mean something, or it's just that the Barcelona ones are in percent and the Magadino per one?
I think if I remember correctly, the scale residual in Barcelona is not is the average over variables, but the scale residual from Magadino is the total scale residuals. So for example, if Barcelona has 80 variables, then this number needs to times 80. That's the previous bug of Sophie, right?
Yeah, previously Sophie was showing for the residuals the average rather than the sum. Was that the question? Yeah.
I think, Marta, you probably did not times whatever variables you used. If you average this, if you need to recalculate the residual, you need to re-average based on the 6.6 or later. or
Okay.
you just simply multiply a number of variables. And also for my case, I have some problems of the error matrix. I just realized there are like, so for example, for my error matrix on 94, at some points it just decreased to 1/10 of normal values. So it increased my scale residual a lot. And because the 9480 was directly calculated by 94 in the frac table, then it just doubled my this problem. So that's why I have quite a big scale residual that I think is not what it reflects. But yeah.
Yeah. Marta, can you send us this presentation?
Yes, of course. I sent it to Ian to this folder, but I can distribute it. Yes.
So I can give you more thought.
Thank you.
Yeah, so I think now everyone should redo the 4443 plot, and to keep in mind the residual is also maybe 100 times smaller if you don't re-average it, and also whatever if you, for example, previously if you plot the sum of the OA variables, all the variables, then it will be the sum of all the variables included the blacklist variables. So this sometimes it will have some mismatch if you don't if you blacklist quite a bit variables. And just let you know, but now Sophie has a new option to either include just the non-blacklisted variables. Okay. Yeah, so any other things we need to discuss? Maybe one more reminder to fill in the classification of your site. Maybe I will. So if you think your data is non-urban, you just select whatever remote or rural. Then I will just classify it to say non-urban and urban. Yeah. Yes. Okay. So for Maricruz, I think you want to see how this QR code was done.
How the? Ah, no. It's okay. I was half kidding. But...
Yeah, I mean, we have some time now. So let's see on this one. I think I have something. Yeah. This one, the QR code generator.
Ah,
You basically put your link right here, then you will generate a QR code.
okay. It's easy. Thank you.
So it's quite easy. I will just say it in the chat. Here it is. Okay. Yes. So maybe we can stop earlier today. Then we keep in touch, and yeah, hopefully we can finish. I mean, I think we cannot submit by the end of March, but maybe we should definitely try the end of April at least. Yes. So any questions, or if that's it, then we can just finish. Good.
Maybe you just ask for a confirmation.
The confirmation of
that the data that you have is really final now.
Okay, let's just ask one more time.
Yeah, just make sure that you really have now for all the sites the final one. I mean, rolling finish doesn't mean final.
Yeah, so for Cypios, I think, yeah, I'm not sure how to deal with your Wi-Fi factor yet. But yeah, maybe it's okay to keep it because it just appeared for a few months, I think, if I remember right.
3 days.
Few days. Oh, sorry.
So you can omit it if you feel like omitting it. That's fine. You can put it in, I don't know if you have a section for special cases. That's definitely a special case. I'm fine with both scenarios, whatever you think.
Okay.
It is definitely not something that was part of the station in long-term sense. It was a wildfire that we just caught for 3 days.
Okay, just a few days. Yes.
And do you see it also? Do you see it with the? You took these 3 days and did PMF in there, or did you include that in the rolling? And how was it resolved? Sorry if you showed it, but I don't remember.
I have shown it. So I did the rolling for the whole period with the specific BB. When I did the A value, I used the specific BB factor from my anyway. Sorry. I ran a special rolling plot just for these 3 days, and I excluded everything, and I just took this the rolling windows that the 3 days were included. And because I understand it was a special event, it was a one-off. It just happened. It hasn't happened since. Not something like this. I also had a different BB. It was a different BB factor than the one I typically get. I put it separately.
Okay. Okay. Just thinking if we could also learn something on how well the rolling resolved in these occasions.
So the normal rolling gave you then a lot of stuff in the residual, or what happened actually with the normal rolling? I don't remember either.
Yeah.
I mean, where did this mass go when of this wildfire in the normal rolling? Did it go to the residual, or did it go to the PBI factor anyway, or to all factors?
Because it was a wildfire event, the OA was massive. It was something like, it depended on the day, but it reached up to 80 micrograms, just the OA per cubic meter. So it was the dominant component, and even with unconstrained, you could get the BB factor quite clearly. The problem was in everything else. For instance, you would get my more oxidized OA.
Everything was
it would have yes, parts of that. So you had to constrain it a bit so to clear the rest. But basically, you just need to remove 3 days out of almost 2 years. It's not 2 years; it's 23 months, but it's fine.
Yeah, I don't know. I mean, are you publishing this soon anyway in an own paper?
Right now, I'm in a COVID-related project, which I have to write because if I don't, the data will go bad very, very soon. And then I will write this, yes.
Okay. Well, it's a question if Ian just refers to your paper then. So not make emphasize it too much. Or otherwise, I mean, sure, one could put something in the supplementary, but if you anyway discuss it separately, one can refer to that. Just saying there was a very local event that was taken up because there obviously the mass spectra that for the rest of the period did not work. But this will be discussed in a separate publication.
Yeah, we can just put PICRIDAS in preparation.
Yeah, exactly. I think it's fine.
Yeah. Okay. Good. So the Athens Q, it's already ready. It's ready. Top SSN from Olga, I think it's. So now we have 2 solutions. One is up to MZ up to 180. But what she sent me was up to 120, if I remember right. So you all have different factors. So for the one has 180 variables, will have a solid field combustion factor, but the 120 will not. That's the status of this. So, but I mean, for the 121, yeah.
Can you hear me?
Yes.
Ian?
Mm-hmm.
Sorry, I didn't have my internet connection is very poor and keeps.
Yeah, go ahead.
So do you want to ask me something about my data or?
Yes, I mean, did I said correctly? I mean, I remember the one you has more MZs. It has more factors, a solid field combustion factor.
Yeah.
And for the one only have 120, doesn't have the factor. So yeah, I don't know which one we should include. I mean, both look reasonable.
Because we can see the variable 115 with the experiment that I sent you. It's up to 120.
Okay. Yeah, so
Ian should use that one up to 120. That's what you're saying, Olga.
I don't mind sending you the other one.
Yeah, but it might be just a little bit inconsistent if you publish your own data, right? Yeah, I mean,
yeah.
So I think you have done almost done for that. Then let's just try the one with high MZs then.
Okay.
Yeah. Good. So the brokenness, I think Stephen can make it work by the deadline. The Brookrest already sent the data with the corrected 44 and 43. The cancel point. So Chunxue, if I may ask, this one is without 29, right?
Cancel point is with 29 because doubling is the same with the case in London that MZ29 sticks out for LVOA. So got removed, and yeah, it shows negative values when with low concentrations also. So doubling its MZ29 removed for rolling.
Yeah, so maybe I guess you can also try out whatever we have mentioned this morning about the multilinear regression to somehow calculate the fraction, to estimate the fraction of 29, then to see how much underestimation we have.
I mean, if it doesn't work, we can try, but if it doesn't work, then I would just report how much is in 29.
Yeah.
What the fraction is, and at least one has an idea about the missing organics compared to the other side. Maybe, but specifically ask maybe all the ones that remove 29 to try to do the multilinear regression, and if it works for all, I mean, we can think about putting them back into some results, or anyway, we should maybe just mention in the supplement what the fraction is that was removed.
Yeah, so I think in Helsinki it looks good. Heisenberg as well. Yeah, so for the Hetamosa, I don't know. Utiala, I got the updated results already with say HOA factor more fresh, I think. I guess all the
Ian.
Right? Yes.
About the inorganics, did I actually send them to you, or did you take them from somewhere? Because I cannot recall.
Yes, so I think, let me check it out. I think, for example, the black carbon, it's not. Oh yeah, you didn't send me. So I basically took some estimated value from your paper to do it.
So I will send you also the data for that. That's all ready, so it shouldn't take long.
So maybe wait a bit. I will prepare a list of all the data later. Then, because I might ask you guys to prepare some results for me.
All right, sure.
Together should be easier for you and me. Yeah.
Okay.
Good. And the Costas, I think it's also finalized already. Also, they have sent me the data already. So previously they have some issues about mixing between the HO and the CCOA. Basically, their co-combustion factor has some morning peaks, and they cannot separate it. Then now they don't have the co-combustion factor anymore. Just have flow factor, HOA, BPOA, and two OAs. And for Karakal, I think Anna is writing her paper already, almost ready to submit. Lily should be also, it's also finalized, as you have seen in Hasna's presentation this morning. and Martino already finished. Marseille, I think Benjamin just need to, probably redo it without people correction. Melpet is also finalized, finished, and London still needs some time just to finish the rolling. Paris just need to rerun the rolling with a proper BBOA constraint. So Xiangwu thought it constrained the Paris BBOA, but it was not, so it has to be rerun. Pildodome, I need to ask for Appling. And Tattoo, I think it already sent me the finalized data. So Zurich, I'm currently running with a constrained cigarette factor. So that's basically everything, all the details for each data set.
So you need to send also a specific mail to Axel.
Yeah.
Tell him about the deadline.
Yeah. I will. Yeah, I think Appling's data should be rather promising. They have, as far as I know, she already had some rolling results. Yeah. Cool. Okay, good. So keep in touch then. I will send you guys a mail afterwards. Yes. Oh, maybe wait a second. We should take a screenshot when you're open your cameras.
My camera doesn't work somehow, so I think I need to restart the computer, but that's obviously not an option with the rolling PMF.
Some people are just black.
How can I? Okay, I'll just do 2. Just wait a second. Okay, perfect. Thank you, guys.
Thank you.
Yeah.
Okay. Bye-bye.
Bye-bye.
Bye-bye. Thanks a lot.
Bye. See you. Thanks.
Bye-bye.
Bye-bye. Bye-bye. Thanks, Jan.
Thank you.
Oh.
Okay, yeah.
Yes.
Last question.
Go ahead.
About residuals. Shall I keep it as it is now, just for absolute, and then it's basically the sum, or shall I just keep the sum for the Q and put the average for all the others?
Say it again.
I mean, now in the latest Sophie we have the sum, right?
Yeah.
That makes sense for Q.
Yes.
But it doesn't really make sense for the others, isn't it?
You mean the scale residual, or
yeah, the scale residuals? Then I mean, there you want to see the average, right? I mean, for Q, it's obviously we need. Oh, sorry, a second.
No worries.